So without further ado, I would like to invite our first speaker for today's event, Ms. Claire Wong, regarding her topic on hospital floors that works resilient solutions for hygiene, durability and safety. Ms. Claire Wong is a graduate of University Malaysia Sabah, UMS, with Bachelor of Psychology in Industrial and Organizational Psychology. She is currently the Resilient and Sports Flooring Target Market Manager at MAPE Malaysia, with over 10 years of experience and strong technical background. In her role, she leads collaboration with installers, specifier and project owners to establish best practice in healthcare and sports facilities flooring. Her key projects include the Sunway Hospital, Pantai Hospital, Perkeso Hospital, Sepang International Circuit and National Tennis Center. And she is widely recognized for delivering sustainable high-performance flooring solutions. So I hope if you have any question in mind, please start it to keep it in your mind. And then because after her talk, we will open for Q&A session. Okay, without further ado, I would like to invite Ms. Claire to the floor. Thank you.
Good morning, everyone. My name is Claire. I'm from MAPE Malaysia. I'm the Target Market Manager for the Resilient Flooring. So today's topic, we are talking about the hospital floors that work. I think when we talk about today's hospital floor, right, it's already beyond or more than it just looks clean, right? Or it just looks nice. It has to be durable. It has to be safe for the patient, and also safe for the medical staff, and also it has to be a sustainable and robust system, because the floor that we have already constructed at the hospital floor, once it's operated, it's very difficult for us to shut down. We don't have downtime, and we need to make sure that to deliver a quality flooring, then only it can be sustainable and it can be last long. All right. So my next slide, I'm going to talk about today's agenda. So today's agenda is actually when we talk about a sustainable system, we have to cover not only for the leveling compound layer, from the adhesive layer, we also need to start from the substrate. Everything is actually started from the substrate, yeah. The substrate is very important because the substrate, a good and quality substrate, is going to receive the resilient flooring on top, and a good and quality substrate also, it can ensure that the material can perform as per our expectation. So I will cover for the substrate requirement, the preparation, until the primer layer, followed by the self-leveling compound, the adhesive, and come into the conclusion. Okay, what do we need to consider, yeah, in order to deliver a sustainable, a quality, a safe, and a hygiene flooring system? So we need to think about the substrate requirement, the preparation of the substrate, a primer, a suitable primer also is needed, is very important. And the self-leveling compound is not just a layer of cementitious material, it's more than that. We will explain more detail in the later of the presentation slide. And of course, the adhesive. I will also like to spend a bit of time to explain about the importance of selected of a suitable adhesive, especially for hospital floor, in the later part. And finally, we'll be talk about the resilient flooring, the vinyl flooring, and also the workmanship, yeah. But today main topic, I will more cover on the first 4 items, which is about the substrate, and also the leveling compound, and the adhesive, and also the primer part. All right, when we talk about hospital floor, right, I can say the resilient flooring for hospital floor is almost everywhere, yeah. It covers corridor, hospital, bed, cafeteria, where else? Reception area, operation theater, etc. Which means to say, good and quality and performance floor is important for us. As I said, hospital operate for 24/7, yeah. There's no downtime allowed. If there's any defects or there's any delamination appeared on the flooring surface, which means to say we have to shut down that particular area, we have to repair it, and it will also raise the concern of hygiene and safety issue, right? Okay, so now we talk about the substrate preparation and also the requirement. Okay, this is the issue that commonly seen at the job site. I think not only for hospital floor, yeah, the ondulation of the substrate. Is that common to happen? Common, right? But it's actually, we have a way to improve this issue, yeah. Another issue, a weak substrate. Is that also common to happen at all the job site, the architects, consultant job site? I seen it every day, yeah. Not only for hospital floor, in some of the factory jobs, and also in a shopping mall, commercial building, and it can be some residential building as well, residential projects. Okay. The third issue. When we are applying the leveling compound on a different types of substrate, yeah, we actually require different types of preparation and a suitable primer. But then today, when we talk about hospital substrate, it's not always a concrete substrate. We are not always referring to a concrete substrate, yeah. Sometimes for some of the refurbishment project, it can be apply the leveling compound on top of a tile surface, right? And also, I have came across with some of the inquiry for my hospital project that actually wanted us to apply the leveling compound on a metal surface. Although this is not something that very easy or very common to see at the job site, but it happens, yeah. And also, we also need to consider when the substrate types is different, if we never taking care about the preparation, we never treat the substrate or the existing substrate, for example, tiles accordingly, we directly apply the vinyl on top. What will happen? If you have a terrygraphing effect, yeah, everything will reflect directly on the floor finishing. It doesn't look good also, yeah. And it will potentially, there's a chances to entrap the dirt, and also potentially will entrap the bacteria on the low spots area. So all these things also is very important for us. So there's a way to improve all these issues that I have mentioned. Actually, the issue I believe is more than these three, yeah? But this is some of the issue that I think is commonly to seen at the job site. So that's why the substrate preparation and also the substrate requirement is very, very important. Same goes to the substrate preparation. Today, when we talk about the requirement, we are not just talking about the concrete layer, yeah. We always started from the ground bearing slab. When there's a ground connected slab, means that underneath is a soil, yeah. So we need to apply a layer of the damp-proof membrane or waterproofing layer. What is the function of that layer of the damp-proof membrane or waterproofing layer? It to stop anything that in liquid form, in water. Waterproofing to stop water. Am I right to say that? And after that, for the undulation issue, we actually need to, always encourage to have a communication with the hospital operation side, yeah? Not the owner, not the client, not the big boss, it's the operator. Because they will know what is the requirement for the floor flatness. If you're already aware that this is the requirement from the client, we need to provide the finishing according to the requirement, right? Then followed by the curing. This is also something that very important, but it's always being neglected. Because, you know, all the projects, or hospital project, or some other commercial, residential, they always tell me, I don't have, I'm short of time, I need to hand over by tomorrow, the next day. But in fact, the actual fact is they only cast the concrete today. So typically, the curing duration for all the cementitious material is 28 days, yeah? 28 days. Minimum is 28 days. Especially for hospital project. In a very confined environment, it might need more than 28 days to allow the material to cure, to develop the full strength, and also to allow the moisture to escape, okay? And the joints also very important, and the design spec is always by the consultant, or the architect, the engineer. Then also we need to cover a bit about the compressive strength of the substrate. So the minimum requirement for the walkway, common area, minimum it has to be achieved 20 minimum, yeah. And for those trafficable condition, trafficable area, then minimum compressive strength we always encourage to go for 30 Newton. That's the minimum, yeah, not the maximum. Okay, and definitely it has to be always power flow to ensure that we have a very solid and also compact surface. Okay. And the substrate has to be free of all kind of the contamination, grease, oil, etc. And then finally, we need to identify the substrate, yeah. It's not always concrete, as I mentioned, yeah. Sometimes it can be metal, sometimes it can be tiles. So different types of substrate, we will need to have different types of substrate requirement and also surface preparation. And of course, when there's a different types of substrate, we need to use different types of primer. Okay, so there's a way to rectify this issue, yeah. If we already know that this will be the requirement, this is what we need and it has to be done at the job site in order to deliver the good job. If there's any ondulation issue, it can be avoided or it can be improved by specifying the correct floor level. Okay, how about the weak substrate? Part of it, it can be workmanship, but I think the most important thing also, we need to know the requirement for that hospital floor. Then only we can specify the requirement, the standard accordingly, and the applicator or the main contractor, they will deliver the job, the finishing as per our requirement, yeah. Okay, and different types of substrate, of course, it can be improved by applying different types of primer and a proper surface preparation method. Okay, when we talk about surface preparation, there's a standard from our side. For all the cementitious substrate prior to the application of all this is leveling compound, yeah, all this is the substrate, sorry, without leveling compound. It has to be achieved the concrete surface profile CSP223. So CSP223 will be something like that. At least you can see the grinding mark. And after that, after we prep the substrate, if there's any defect, there's any low spot, there's any crack, we have to repair it accordingly by using the suitable material. Okay, now we will move to the primer. I think this is also an issue that commonly seen at the job site, yeah? Have you ever found that your vinyl flooring at the hospital project have this issue? Blistering? Yeah, right? Blistering, bubbling, or delamination. What do you think the possible causes of to contributed to this issue, yeah? Oh, you're very smart, yeah? It's actually because of the untreated substrate with high moisture content. I will keep repeating this moisture issue in my next few slides, so you have to bear on mind and remember on this. When we say high moisture, means that the moisture content is more than 4%. Yeah, I will explain why in later slide. Okay, so this is very common to see at our job site. Because why? Very common that when we go to the job site, when we are trying to propose our system to the contractor, we will always ask them, is there any leveling compound that you are going to apply on a ground bearing slab? So the first question will be, is the waterproofing material applied? The waterproofing material is to stop anything that in liquid, waterproof, right? And the second question that I will also always like to ask them is there any moisture reduction barrier that already specified in the BQ? My answer is sometimes yes, sometimes no, yeah. For those that answer me no, definitely they won't apply, right? Even the substrate moisture level is high. Why? They don't budget in. They don't have extra budget to provide the additional layer of the moisture reduction layer. As I mentioned, moisture is something that in wearable form, in gas form. I cannot see by my naked eyes, yeah, but it's something that appeared and it's like a hydrostatic, a rising dampness, a residue moisture inside the concrete substrate itself. Eventually, if I'm going to apply a very damp surface with a layer of vinyl, impermeable, right? It's like a plastic, right? What will happen? Definitely, if you have the blistering effect due to the osmotic process. Okay? So, as we already talked about the substrate moisture content, so the industrial guideline is we always refer to the 4%, yeah? This is the guideline, 4. So you can measure it by using a moisture meter. So when we talk about moisture content, you have to refer to the red color scale here. 4 means the moisture is high. Anything below 4 means the moisture is low. Or there's a guideline for the resilient flooring, which we talk about the carbide method. CM is carbide method. You can also measure it by using the same moisture meter, but you have to refer to the yellow scale. So here you see here, yeah, when I say 2.5 means refer to the 4% of the MC content, moisture content It is the same. It's just that we are using a different guideline and different unit to measure it. All right. Okay. So this issue, it can be improved or it can be reduce the chances of blistering that happen at our job site by applying a layer of the moisture reduction barrier. So this is very, very important because I've seen there's a lot of hospital flooring. They are using the vinyl flooring on the ground bearing slab, but there's always a missing layer. The most important layer, moisture reduction barrier. You imagine, yeah, once we already move in, maybe first week, second week, no issue. But once the pressure, the moisture pressure accumulated, right, into certain strength that when it's already strong enough to push away the vinyl, so we can see this. But when the time that you already identify this issue, right, you already move in, the hospital already operate. What we need to do, we need to shut down that particular area. And most of the time, we don't have that time of luxury. So this layer is very important, especially for hospital. Okay. And now we move to the leveling compound layer. As I mentioned in the first few slides, leveling compound layer is something that more than just a cementitious layer, yeah. It's not just a layering the material that able to resurface or improve the ondulation of the existing substrate in order to receive the vinyl. There's a lot of things that we need to consider when we need to select or we need to specify a product. Because of there's a lot of things that it will related to the durability of the flooring system, the hygiene, and also the safety. Okay. Have you seen that before? Dented ondulation. A hospital flooring that is always subjected to a lot of dynamic movement, static movement in different magnitude, different stress, right? When the leveling compound that we applied at the job site is not good enough in terms of the compressive strength in order to resist of all these movement and stresses, right? Potentially it will become dented, yeah, because when the hospital equipment move around, the stress are not able to distribute evenly. So the weak point, it will form all these dented mark, yeah. And this is actually very dangerous, especially for the hospital patient, for the medical staff who actually will always walk on the resilient flooring surface, or when you're pushing away some of the medical equipment on all this bumpy area, yeah, it can be very dangerous as well, yeah. Okay. And also, yeah, the hospital bed is always subject to all this mechanical loading. Okay. So these are the criteria that we need to consider when we need to select an appropriate hospital underlayment material. I will go through one by one. The first one will be the mechanical performance. So you have to recognize this logo, yeah. This is compliances to the standard of 13813. I will explain more details in the next two slides. And also, we need to consider about the thickness, right? Not sometimes my client will tell me that I need a floor that actually can achieve a 5 mm, 7 mm thickness. I need to top up the leveling compound that in 10 mm thickness, right? So we need to consider that because when you have different types of thickness that you would like to top up, there's a different types of leveling compound that need to use, yeah? Okay, and of course the waiting time before laying the flooring, you know, as I said, they are short of time, everything needed to be fast, so you have to consider of the waiting time before bonding. For those fast track project, you will need to consider a more fast curing material instead of the normal or the standard of the leveling compound. And also, this is not common in Malaysia, the suitability for underfloor heating system. Okay. And also fiber reinforcer, this is also not common, yeah, not common to happen at our job site in Malaysia. But in some of the European countries, they will use this when they need to apply thickness underlayment material in a very thick layer. So there's some reinforcement material that needed to add in order to increase the strength of the material. And we need to consider, is this used for internal or external? And I think so far for hospital flooring, all the vinyl flooring is only for internal use, yeah? Right? There's no any external resilient flooring or vinyl flooring, right? In hospital project, right? Okay. And the green label, either is Singapore Green Building Products or EC1 Plus. And I will explain more details about these two certifications in the next few slides or so. Okay? So, you see, a layer of simple cementitious material is actually, there's a lot of factors that we need to consider before we select the appropriate material to be applied at the job site. Now, if you still remember this logo, this standard EN 13813, yeah? This logo for me is very important when this can become one of the selection criteria when we need to select the suitable self-leveling compound to be applied at the job site. Why? CT. What is CT? CT represent means it's a cementitious material. And here C25. Can you guess what is C25? Yes. You have any gift for this very smart person or not? Joseph. She always answer the right question, yeah. C25 means grade 25, okay? And what is F7? Just guess, just guess. So that you all won't fall asleep. I know it's very difficult to attend the product talk in early morning, especially on Saturday morning. Same goes to me. What is F7? Just guess. Fractural strength. So fractural strength refer to the maximum bending of the material before it breaks, yeah? So here, when I show F7, means that the fractural strength is 7, okay? A2. Anyone know? Or you only know A4, A4 paper? Okay, A2 is actually is a fire rating classification, yeah. When we say A1, A2 in Euro class means that this is a non-combustible material. When I say that this is a non-combustible material, meaning to say that this will not burn, yeah. This material will not burn. It will not spread fire, it won't catch fire as well. Is that important? A non-combustible material to be applied at the hospital floor, it is very important. Do you have any idea what are the examples for the non-combustible material? Cementitious material, concrete, steel, for example, okay? And FL is referred to the flooring material. S1, when I say this is non-combustible, S1 refer to S for smoke. S1 is referred to low smoke production. This is also very important, yeah. I realize that most of the time when we are selecting a material, the leveling compound, we just think that it's just a leveling compound, a layer of cement, but this is more than this layer, more than a leveling compound. If you give you a green certification, if you give you strength, if you give you a fractural strength, and it is a non-combustible material and with a very low smoke production. Okay, so this is about this EN standard, yeah, 13813. Okay, so if let's say all these issues happen that we can see at our job site, it can be improved by using a high mechanical strength self-leveling underlayment material. Okay, and now we will move to the adhesive layer. Okay. Adhesive layer also is something that I think, I have a feeling, maybe I'm wrong, that most of the consultant, the hospital owner, even the operator, the hospital operator, they are not really concerned about this layer. For them, adhesive is just the adhesive, right? Nothing special, nothing fantastic about this material. And the message that I would like to pass here today is the adhesive is not just a simple adhesive. There's a lot of things, a lot of selection criteria, a lot of factors that we need to consider in order to ensure that we are providing a quality air to the hospital patient. We are providing the material that is compliant to a lot of ISO standard. I'm going to explain it later. And also in order to provide a more a healthy environment, not only to the patient and also to the medical staff, because they are the one who always work there, right? Okay. When we talk about adhesive, as I said, there are three components that I feel that is very important. This is the test, the performance test of the adhesive material, that it has to be compliant to the ISO standard 22631. So in terms of these three tests, yeah, dimensional stability, we talk about peel strength, we talk about shear strength. When I talk about this test, right, maybe some of the operator or the client, they feel like this is not related to me. I just need a layer of the adhesive that able to adhere to the substrate. That's it. But there's a lot of things that we need to know what is this test regarding. Then only we know why I need to select the adhesive that compliance to these three ISO standard. Okay, the first one is dimensional stability. Dimensional stability for the adhesive material is very, very important. Why? Because of the material that is actually dimensional stability approved, right, or pass the test, right, it means that the adhesive able to withstand or hold the vinyl in shape without changing the shape, yeah. And this is very related to the job site condition. You imagine the hospital floor, I guess it's always turn on the air conditioning, yeah, very cold, right, most of the time. But in some of the area like windows, corridor, or maybe the entrance area, it will be subjected to some sunlight as well, right? So in this kind of temperature changes variation, right, if the material that is dimensional stability, it will remain the same shape, the same size, it regardless to all these temperature variation changes and all this expansion and contraction. Okay, now how are we going to test this? Yeah, you imagine, yeah, I will put the sample. This is the vinyl flooring adhere with the adhesive, and this is the base, yeah, and we just put it inside the oven for a certain hour, and we take it out, we put it in an air conditioning condition for a certain hour. So they will go through this kind of cycle. And end of the day, we will see after a multiple cycle of the testing, is this material still able to remain the same shape or not? So this is how the test conducted. And what if today we are using adhesive that is not dimensional stability? Can you guess what is the potential problem that will happen at the job site? Shift where you can see a gap. I think very common, yeah. I've seen it almost every day at the hospital job site. So this will be the situation that you'll be able to identify. Is this dangerous? It's dangerous, because today we are talking about hospital floor. So this area that already exposed, right, due to the unstable of the dimensional stability of the adhesive, right, potentially it will also entrap the dirt, the stain, the bacterial, and also very difficult to do the cleaning over this area. And potentially all the cleaning detergent will also seep into the leveling compound material. When the leveling compound exposed to water, what will happen? Cement exposed to water, what will happen? It will soften the chemical linkage, and it will be lead to the delamination of the flooring system. And this also directly related to the safety of the hospital environment. So this is something that very important. A good adhesive, it has to be fulfill this criteria, one of this criteria, which is dimensional stability. Okay, second test, we talk about peel strength test in 90 degree. This is how the test conducted, yeah. They will put, it's over here, here. They will put the adhesive under the substrate with the vinyl flooring, and they will peel. Why we say 90 degree? Because they will peel the material in a 90 degree in order to test the maximum tensile force. So after this test, also we will evaluate the failure mode, whether it is in terms of the cohesive failure, or adhesive failure, or substrate failure. The worst case scenario that if let's say the adhesive that we are selecting, they are not passed this test, right, means you can see cohesive failure. What is cohesive failure? Cohesive failure is a failure that break in between the adhesive itself. This is something that very bad. Means that the adhesive is not strong enough, yeah? Okay, So this is how the test conducted. You see they will pull and they will also measure the maximum tensile force that they are able to take it. Is this related to the hospital flooring? Related, right? Example, today when we are the hospital cleaner, they are doing some cleaning, especially on the edges, is always the weak point. If let's say they already we have a multiple time of cleaning, pushing, right? If we have chance to lift up the material, right? If the material that we are using, right, is not good in terms of the peel strength, right, means that the edges will potentially curl up, yeah? And this is also dangerous because people might trap and fall down on the curl up area. Okay, so this is also related to us. And now we move to the last test, which is about shear strength. Shear strength is to actually test the force that the material able to withstand to hold in a parallel direction or in a sideway. Sideway means front and back or left and right. This we call sideway. And this is also very common to see at the hospital flooring. Yeah, imagine today we are pushing the hospital equipment. Sometimes they run fast and maybe there's someone in front of them, so they have to stop immediately, pull back and pull out. So front and back. This is because sideway force. So when the adhesive that is actually not good in terms of the shear strength, right? After multiple time of the pulling sideway force, right? Potentially, if you give way, yeah. Then the vinyl flooring, what will happen if you have a sliding effect? This is actually also very dangerous. When imagine in a hospital, everyone are very urgent. Everything is very, they need it fast. They need to settle it fast. So when you are trying to run, then the vinyl flooring is already give way, right? Then it will fall down, yeah. So it's also very dangerous. So material that actually pass the shear strength test is important as well. As I said, this 3 ISO standard is important. It's one of the selection criteria for the adhesive in order to ensure the performance or the mechanical property of the adhesive is there. Okay? Now, from the adhesive layer, we also need to talk about the, I see later we have a talk about the GPI building, right? So we have an expert here. So I will just cover about the product. When we say VOC, I think this is very important, especially nowadays we are looking for a more sustainable building and also very important for hospital project. But the definition of VOC, I will explain. Yeah, I will explain about the definition of VOC when we talk about VOC admission and VOC content. That's a difference, yeah? Okay. Here is the definition of VOC admission. VOC admission is the volatile organic compound that released by the product in the air. This is admission, all right? And it measures in the admission chamber, so it's compliant to the ISO standard 16000, Part 369, and the EN standard 16516. And the unit, measurement unit, is actually in microgram per cubic meter, because we are talking about the release in the environment, right? We will test everything in the chamber, in the admission chamber. So when we talk about VOC admission, we always like to relate this to this standard, yeah, EC1 plus. This is a European standard, but I think this is important. EMI could material that's certified for low emission, EC1 plus is actually very low emission. Meaning, doesn't mean that totally zero VOC. It doesn't mean that. There's still some VOC content in the environment, in the air, but very, very little. Okay, very, very low. I will show you the table later. Now, we move to a VOC content. When we talk about the VOC content, it's actually, we talk about the content inside the product itself, the product. The first one is talking about the air quality. The second one talking about the VOC inside the product. And it's actually calculated by, evaluated by the titration. Okay, and also compliance to the standard ISO and EPA method. So the measurement unit is gram per liter, And this is something that very related to the VOC content, which is Singapore Green Building Product. So one of the testing criteria for Singapore Green Building Product is about the VOC content inside the product itself. Okay, so this is the emission test chamber. So basically they will put the sample inside the test chamber, and they will have two tests, yeah. 3 days is actually the pre-test. Normally the manufacturer, they always like to conduct the pre-test, because when the pre-test result is good, it automatically means that the ultimate test result 28 days they can pass. Okay, so normally for the testing body, they only need to have the 28 days result, and they are measured in different measuring unit. Okay, now we talked about the VOC emission comparison. Why I need to show this table? Because I feel like I do not know whether all the architects here realize or not, yeah. At the job site, hospital job site, actually there's a lot of applicator, they use the solvented adhesive. You all realize, right? A lot of applicator use because a lot of time when we visited the job site, it immediately gives you a very strong smell, even though when they are applying a vinyl flooring material, they will still use the solvent material. Okay, and this is very bad for the worker, actually, for the worker, because hospital is a totally confined area. Yeah, when I visited the job site for 1-2 hours, I already cannot take it. Very strong smell. It makes you feel very uncomfortable. A lot of irritation. Okay, so this is the comparison for a solvented material, solvent-based adhesive, water-based adhesive, and a low VOC adhesive, which compliances to EC1 plus. Yeah, you see, we talk about the pre-test 3 days. This is the amount microgram per meter cube that we have for the solvent material. Water-based, much lesser. All right. About VOC, low VOC material, much lesser, less than 750 microgram per cubic meter. How about 28 days? Why the 28 days figure is important for us? Yeah, you imagine, yeah, sometimes when we are renovated or we are applying the vinyl adhesive at the hospital job site, maybe we need to move into the hospital after 28 days. So this is the figure, the figure that after 28 days. So when the material still remain high, yeah, 2,000. Water-based, much better, 1,000. What about low VOC? It's less than 60 microgram per cubic meter, which means to say that this environment is already safe for us to move in, is already safe for the patient and the medical staff to stay in such an environment. It's already very low, yeah. Okay, so I think this is one of the points that we need to consider when we think about the suitable adhesive for hospital flooring. Water-based, for me, is not good enough. We have to always try to go for the material that compliances to the EC1 plus standard. We can show you the test report normally, because if let's say the manufacturer able to show you that, okay, my adhesive compliances to this test, right? We need to show you the test report as well. Yeah, so we have to always identify this logo, not the Singapore Green Building material. Yeah, this EC1 Plus import. Because I realize that sometimes when we are trying to show this test certificate to the consultant, they are not too interested when I mention about this. But in fact, the VOC emission in the air is very important. So I think we have to always think about this certification. Yeah. Okay. No, it's a European standard. But for some of the manufacturer, they are not only to send the product for the EC1 plus test, they also will send the product for the green certification. Yeah, so we have both. I think will be even safer for the hospital project, right? To which ISO? I think Malaysia standard, right? based on what we have dealt with the architect in the past, they are more prefer to have a Singapore green label as comparing to the EC1 plus standard. To the green, right? CRIM is totally not related to the green, because CRIM cert, normally what we do is we will send the product for performance test, right? It can be a lot. Example, leveling compound. It can be compressive strength for the first 28 days. Yeah, so it is not related to green, yeah. I'm not sure. I think we can check with the expert later, the next speaker. I'm not a certified person to talk about this topic, sorry. But we can discuss later if you have any input from the next speaker, yeah? Okay, and also adhesive that we selected, right? It has to be compliant to this standard, non-flammable. When we talk about solvent material, it's not non-flammable, yeah? It's not a non-flammable material. So when I thought about the leveling compound, I have mentioned that this is a non-combustible, right? Non-combustible meaning that it won't burn at all. It won't burn, just like steel, like concrete, right? Cementitious material. When I say non-flammable, that means that the material, if you still burn under certain extreme condition, okay? But if you use a solvent material, it's not a non-flammable material, yeah? Okay? So a non-flammable material is very important in the selection. It is important component in one of the selection criteria for the suitable adhesive, because we don't want to have a material that able to spread the fire at the hospital job site. It is very dangerous. And this picture I took at the job site, yeah, also a hospital project. Can you see that? It's flammable, with a lot of hazard logo, but they're still using it as an adhesive. So this is something that I think we need to raise our awareness about to using appropriate adhesive material on the job site, and also for the selection of the underlayment as well. It's beyond that, yeah. It's not as simple as what we think. It's just a layer of material. It's not that. It's beyond that. Okay, so I'm coming to my conclusion. I think I'm on time, a bit earlier. Okay, there's 4 key factors for a very more hygiene, a durable, safe hospital floor, yeah. For me, there's 4 key important factors. The first factor is the substrate condition. As I mentioned, substrate is everything, foundation of everything. So we need to make sure that we are specified the correct material at the job site, the correct specification, then only the applicator or the main contractor able to deliver as per the requirement. And the environment factor that I'm actually referring to, not only a low VOC emission environment, because we need a very hygiene and very safe environment, right? I also refer to the job site condition. For example, today, if we need to construct a clinic, not to say hospital, at Genting Highland. So at Genting Highland there, all of us know that the relative humidity is very high. In that kind of situation, it's actually the curing duration of the leveling compound will be much slower. But do we need to rush for it to complete the project? My answer is no, yeah. Because today, we always talk about hygienic, durable, and safe hospital flooring. We still need to allow the proper curing duration for the leveling compound or for the concrete substrate in order to allow the material to achieve the ultimate strength, then only we can proceed to the next layer. So if there's anything, the environment factor for us is hard to control, I know, but we always not supposed to in hurry to complete the project without considering a durable or more sustainable flooring system, okay? And of course, the workmanship, we need to appoint a very skilled and good applicator, because no matter how good is the material that we are introducing, how good is the specification, how good is the product that you are using, if let's say the applicator, they are not applied the material according to the specification, it won't turn out good as well. Okay, Lastly will be the material. Suitable material, like what I say, non-combustible material for the self-leveling underlayment, a suitable primer for the moisture reduction barrier to tackle the moisture issue, and the adhesive also a non-flammable, solvent-free, low VOC material also very important. Okay, so that's all for my slide today. Thank you.
All right. So before I open any question to the floor, are we having the Slido? Or anyone prefer to talk directly to the mic? Any question? Maybe you can sit at the center first. So many people. Any question?
Yeah, a question on what happens after. Hospitals requires constant maintenance and upkeep. One is what's the durability and duration of the product. The other one is what are the prescribed preventive and predictive maintenance that can be put in place. Is there something that's been taught on this line of questioning or this line of needs?
When we talk about the repair duration, right, this is something that we cannot avoid, especially for hospital project, because always subjected to the heavy usage, right? So we will need to identify the area and the problem first, yeah. Example. Yeah, it's not repair. It's to preventive maintenance. Actually, there's no preventive maintenance. The preventive maintenance is you do it right at first for me. If you do it right, you select the appropriate material from the substrate until the final layer, right? I don't see any issue will happen.
Even though you have this done right, it still needs upkeep. So what are the prescriptions on that? Do you have any timeline on that?
Okay, for me, right, as I said, if you do it right from the substrate until the leveling compound, until the adhesive layer, right, there's almost no maintenance. I can easily say that the floor easily can last more than 10 years. The only thing that we need to maintain is on the floor finishing surface, where the vinyl finishing surface. Maybe after a while, when the vinyl flooring subjected to some exposure to after traffic, the color will fade out and it will wear off. So that is more on the aesthetic value. So that's why I always emphasize is doing right at first is very important. When you do right, it can last more than 10 years. So 10 years later, if we wanted to know what we can do after 10 years later, right, is maybe just to maintain the floor finishing surface.
Maybe I put it in this format. Architects, what we are, we constantly have to justify why it needs to be done right. Number one, if it is done right, and then what? How long does it last? What happens next? Now, those are questions that's relevant in justification too. It doesn't stop at the point that just do it right, do the work, and then go off. It's done. We are liable for buildings for the rest of our lives. So even if it deteriorates, we need to understand what that picture looks like.
Okay, so if you wanted to know something that beyond just doing right, so another thing that I can think of is related to the user behavior. So when we are, the way that we handle the equipments, the tools, it has to be in a more gentle way, and we have to ensure that there's no very sharp point load that will actually potentially stress on one point of the flooring surface. Then if you thought about the maintenance, just now I mentioned that if you do it right, it can actually easily last more than 10 years, right? What about 10 years later, right? So 10 years later, other than the vinyl flooring material, it will be wear off, the color will be a bit fading here and there. There's also potential that the leveling compound area will have a little bit of compression due to some heavy traffic, heavy usage. So for that particular weak point or the dented area, what we do is very easy. If let's say the substrate is good, yeah, then we no need to repair the substrate. We just remove the dented marks on that particular area, and we can conduct some localized repair. So what we need to do is to remove that particular area, the vinyl, and then we remove the dented layer of the underlayment. We patch it back by using the appropriate primer and leveling compound, followed by the adhesive, then covered by the vinyl flooring.
Okay, all right. I think almost there. All right, so we have one question. What will be the solution for floor where the area has high condensation from time to time?
When we say high condensation, right, is most likely is due to the different temperature, right,
yeah.
in different area. Maybe the other one side is M&E room, which is very hot, and the other side of the room, it might be a hospital bed that always turn on the
24
air
hours,
conditioning. So for the resilient solution, we don't have solution for that, but what we can do is I can actually suggest to add the layer of the insulation on the other side of the wall to make the temperature become equivalent, so that it can actually help to improve the condensation. And also, I guess ventilation also, it will help, yeah, to improve the condensation.
I think the question is a solution for floor.
We don't have, you need insulation. Sorry, my answer is we need insulation. We don't have that solution, yeah, because it's due to the temperature difference.
Oh, okay, all right. Any other question? You can even write in the Slido. Anyone? Okay, I have one question. From an operational and hygiene perspective, what are the most common flooring mistakes architects still make in hospital, and how can resilient flooring system prevent them? Any kind of mistake that you commonly see when you...
It's all the photo that I show in my slide. I think all this is very, very common, yeah, from substrate strength, low strength, until the floor levelness. And then that's about the substrate. And also the missing part of the moisture reduction layer is very, very common. I think out of 10 projects, maybe 8 projects, they don't factor in the moisture reduction barrier to actually cater for the rising for the residue moisture issue, the high substrate moisture issue, and they also always neglected this part will be the adhesive part, which is for me is important, yeah. So actually I covered all in my presentation.
Okay, I have one question here. Any acoustic performance for MAPE flooring system?
We don't, our flooring system, the layering that I showed earlier, actually it doesn't contribute to the acoustic value at all. So when we talk about acoustic value, if you are concerned about the dampening sound, then you can consider our another product range, which is a soundproofing system, that material called MAPE Silent.
Okay,
Yeah.
I think we can continue with the product presentation, so at least we can understand under that perspective.
Okay.
Right, thank you.
Continue the slide. Okay. Now, just now we talked about some site issue that are commonly seen at the job site. We talked about the issue. We talked about the solution or the best practice. And now we have to link back to the product that we have, yeah, in order to address the concern, the issue that I've highlighted earlier. Okay. In MAPE, when we talk about the resilient flooring system, we will always tie back with the complete system solution, from the primer, the substrate preparation, the requirement, the repair material, priming coat, leveling compound, adhesive, until the final finishing layer. This is important as the good practice to construct a durable floor. My first presentation slide, yeah, because a complete system solution can ensure that we are providing the entire full system to the market, to the consultant, to the architects, and also we can ensure that each of the layer, it will perform as per our expectation, and all this layering is also compatible. Okay, we talk about the repair method. There's some issue that commonly seen at the job site, like example, crack, then the crack that less than 0.3 mm, and there's a surface crack that within 0.3 to 1 mm. So all this, it can be repaired by using this product called Penny Prep SC. So this is a product that actually can repair from feather edge to maximum 5 mm, pre-packed product in 5 kg per bag, 4.5 kg per bag. So very easy to carry and to bring over to the job site. But the message here is not just the product, yeah, I think. The message here is if we are able to identify any defects on the floor substrate, we need to repair it accordingly. Very common I've seen, yeah, they don't have this practice at the job site. Because all this imperfection on the substrate, it will definitely reflect into the leveling compound layer. And finally, it will appear on the vinyl flooring layer. Okay, this is about crack. And low spot, common, right? We also can repair it by using the same product called Penny Prep SC. Anything that less than 5 mm until feather edge. Feather edge means almost without thickness, scratch to 0. Then we still can use this product to repair it accordingly. And if you are able to identify some localized repair that's in between 5 mm to 10 mm thickness, very common also. We can use a patch repair mortar called Mape Grout Patch 218. This is a fiber reinforcement patch repair mortar, so a very thixotropic material, okay? And this is also common. Sometimes when we go to the job site, the client will tell us that, oh, I need to top up the existing screeding layer. There's a solution, yeah, a part of the site mix method. We don't really encourage on the site mix method because of we found that the quality is always inconsistent, right? The site mix method. So it might be some of the spot, the strength is high, some of the spot is very low strength, and we have impact of the performance of the flooring system as well. So in this case, we are introducing a pre-packed screeding material called Top Chain Pronto, pre-packed in 25 kg bag. And this material is actually very high strength, yeah. After 28 days, the compressive strength of the material is actually more than 35 Newton. High, right? For the hospital floor, it's high, right? And also, this is a very fast curing material as compared to the normal cement sandcrete at the job site, which require 28 days for the curing duration. Okay, so to top up the existing floor level, we will always propose to use a pre-pack method. Okay, so this is the repair. So after we repair the substrate, what we can do is about the primer. Just now I keep saying about the moisture, right? We have a system that actually suitable to use for the to use as a moisture reduction barrier. A common primer that we are using is actually primer G. You can see in blue color, so it can be applied on all the elevated floor. But in some case, we talk about different types of substrate, right? We need to use different primer. If today we are dealing with a substrate where it's a tile surface, we cannot use primer G anymore because primer G is a one component resin-based primer. Only can be applied on all the cementitious substrate. If we say about today, we have to deal with the tiles finishing, what we need to do is we use a more high performance primer, which is in this case, I would like to introduce this primer, which is a universal alkalic primer for all the absorbent and non-absorbent substrate. So one of the example for non-absorbent substrate, it will be tiles. So normally what we recommend for tile surface, you still need to dry, yeah? Because some tiles that we have seen at the site, there's a layer of a very glossy, oily surface, yeah? We cannot apply the primer in that kind of finishing. We have to remove it by using a grinding method, or you can use the caustic acid to actually remove the glossy and oily surface. Then, tile to tiles, there's a joint, right? We also need to repair it accordingly by using Penny Prep SC. Okay, Because if you don't repair it accordingly, after you apply your leveling compound and vinyl, you can see all the tiles will reflect on the finishing surface. After we touch up the joint, the grout, we remove and we prep the tile surface, then we can apply this primer. Okay? And for some job site that we are always there's no downtime allowed, they want to, after apply the primer, immediately apply the leveling, there's an option from our side which is a 2-component solvent-free epoxy. The material is eborib, yeah. So the good thing about the eborib is you can apply the self-leveling directly on eborib while the material is still fresh. But for these two types of the primer, right, you need to wait until the material become tack-free. A bit of tackiness, but not wet. That kind of situation we call tack-free. Then only you can continue to apply the leveling compound. Means there's a waiting time for this primer, 2-3 hours, depend on your environmental condition, but there's no waiting time for eborib. Okay. When I said about this universal primer EcoPrim T plus AP, why we said it as a universal primer, because of it can be applied on all the non-absorbent substrate. It can be applied on existing epoxy or polyurethane primer. On surface, it can become a primer. It can be also applied on existing alkylic adhesive residue. This is common, yeah, for renovation. This is common, right? And also it can be applied on ceramic tiles and a stone surface. Okay, so all this we call as a non-absorbent surface. And also it can be applied on absorbent substrate as well. It can be applied on a normal cementitious substrate. So that's why we call this as a universal primer. Okay, now we move to the moisture. We thought about the moisture. If let's say the substrate moisture is more than 4%, we need to apply a layer of the moisture reduction barrier, and this is the suitable product. The product name called Planicil VSMY. This is a 2-component solvent-free epoxy, 100% solid content. The material viscosity is very good, yeah, which means to say that it is able to penetrate into the concrete substrate. Okay. The penetration is very, very well also. And then this will be the layering. Typically, we require 2 layers. The first layer is very important because this 0.4 kg per meter square, it will be add as a moisture reduction barrier. So anything that we apply, right, it cannot be lesser than 0.4. It has to be minimum 0.4. And the second layer is actually a bonding layer in order to allow the leveling compound to be bonded on top of this material. Okay, this is how we conducted the test for this moisture reduction barrier, and this is an important test as well that compliant to the standard ASTM E96/5. This is a standard test method for water vapor transmission of material. Why this test is important? Because just now some architects asked about the common mistake, right? Other than they never specify or they are not concerning about the moisture level, right? Some of the applicator also, they will use a cementitious material to use as a moisture reduction barrier. A lot. Maybe sometimes the consultant and the architect not aware about that. The cementitious material that I'm referring to is a cementitious material that we use to propose in the toilet area. That is a waterproofing layer. As I said, waterproofing layer is used to stop anything that in liquid form, water. Moisture, we are not encouraged to use the cementitious material because it serves different purpose, right? So this is also very common to see at the job site. That's why this test is very important, because this test is able to tell us how the moisture reduction material works as a moisture barrier layer. Okay, so this test, how we test, yeah, we also we use a testing tray. This is a testing tray, and we will fill up with a lot of distilled water. So, and we will seal up by using the tested material. In this case, it will be Planicil VSMY. And of course, we have to seal it up, the perimeter of the tray by seal with sealant. So in this environment, it's actually very high in vapor pressure, right? Because it's full of water, it's 100%. And in the testing chamber here, right, it's actually low in water pressure. So what will they do, right? They will, this is a cup measuring method. They will measure the weight before they put inside the chamber. And for example, they will put it there for 24 hours. So after 24 hours, they will take out the measuring cup and then measure the weight again. So that's a cycle, multiple cycle that they will go through. So end of the day, they will measure, right? There's two things that they will measure, yeah. First thing is the losses of the weight for this testing tray in order to test how many gram of this water vapor able to escape via this layer in meter square per, it can be per day or per hour, yeah, depends on the test body, okay? This is the first test that they will test a figure that they will pick up from this test. Second thing, from the test also we can know that in this 100% RH, right, after we apply this area, this layer of the material is able to actually filter approximately 96% of the RH, means the leftover RH already become insignificant. So that's how this layer of the material work, yeah, which I think is important because I seldom see this kind of test report that the supplier or the architect will ask for it, yeah. But in fact, when we are applying something at the job site, we should know how this product works, right? Is the product already gone through those professional testing under certain body or not? And we need to know how the test is conducted. Then only we will have confidence on the product, right? So this is very important for me, this test, yeah. SCM E96/5. Okay, and we come to the self-leveling underlayment. So for hospital flooring, I will always propose to you ultra plan contract. Reason being is this is a very high compressive strength material. After 28 days, we can achieve 32 Newton. And this is the product that this is also the product that complies to this standard EN 13813. Okay, I don't want to explain everything detailed, which already presented earlier. And this is also a product that actually certified by Singapore Green Building Product. And of course, also compliances to this EAS EC1+, which is low emission, VOC low emission standard. And finally will be serum. Okay, so this is about the leveling compound. And we talked about the adhesive, yeah, as I said, in the market or at the job site, we always see that even for hospital project, they always use a lot of solvent material, solvent-based adhesive, and also sometimes they will use some alkalic-based adhesive. Okay, so the adhesive that I'm going to introduce is Ultra Bond Eco V4 Universal. This is also a universal adhesive. When I say universal, means that it has multiple usage. Yeah? The universal meaning other than referring to the high performance of the material, I also referring to the application of this adhesive, which means to say this adhesive, it can apply in all types of vinyl flooring. It can be vinyl roll, vinyl plank, rubber flooring, linoleum, etc. Okay, and the important test that I mentioned, dimensional stability, peel strength test, shear strength test, all pass, yeah. Okay, and we have extended open time and fast initial tag, which means to say that this will be benefited to the worker because they have more time, adjustment time is more, yeah. And also two different packaging. It's ready for use after minimum 24 to 48 hours. And this is a product that actually solvent-free, low odor, yeah. And also very low emission, compliance to the EC1 plus standard, low VOC emission. And also certified for Singapore Green Building Product. And of course, non-flammable, okay? And also the serum test. Okay, so this is the universal adhesive that I refer to. As I said, it can use to bond on rubber, homogeneous PVC, heterogeneous PVC, linoleum, and all the vinyl flooring, the resilient flooring that you can think of. Okay, so yeah, this is about the application of the universal adhesive at the hospital job site. I have a project here that I would like to share. It's a case study. This is about Sunway Medical Hospital. It might be some of the project that under the architect here who attended today's presentation. So Sunway Medical Hospital is one of the very famous, very well-known hospital in Malaysia, right? Actually, not in Malaysia. They also attract a lot of medical tourism that come to Malaysia to have the treatment or healthcare screening in Malaysia, yeah, because of a very good facility, and also there's a lot of Sunway hospital in Malaysia, not only in Kuala Lumpur, yeah. Okay, so this is the #1 hospital in Malaysia, and we have started our project with Sunway Medical Group, right? With this, this is our first project, Sunway Medical in Sun City. So I remember we have started this project right after COVID time, because of there's a lot of shortage in hospital bed, even though now, yeah, not talking about few years back, even though now there's a lot of shortage as well, right? So they have extended the existing building to another tower, which is Tower D and E. So back then, 2023, right? Okay, that's the first project that we have started with Sunway, and during that time, we only able to supply our primer and the leveling compound, ultraplan contract only. But in the later part, right, we also explore more with this client. Then we are also, they are also using the same system to this Penang project, Sunway Hospital Penang, because they have a good experience with us for this Sun City project. And also followed by Velocity, yeah. Velocity, they also have 2 phases of construction. The first building and the extension of the Velocity Hospital, yeah, it just completed last year, the extension of the hospital block. And also this is in Damansara, and the last one, the most recent completed one, which is on year 2025, is the Sunway Medical Center Ipoh. So actually my intention is not to show you that how much of floor covering that we already supplied under Sunway Group. I would like to share how we deal with the different job site condition. This is one of the typical example. The substrate that very high in moisture, this is Sunway City, Sun City Tower D. And this is not a ground connecting slab. If you remember, if we go to Sunway Medical Hospital in Sun City, the ground floor is tiles. Very nice, some people playing piano there also, right? This is happening on the elevated floor. But what happened is, for elevator floor, after they cast the substrate, right, we went in and we measure the moisture level, right. The moisture is extremely high. Just now I say our standard is less than 4%. We measure by using moisture meter, right, all the spots, right, more than 6. Means the moisture level is extremely high. So the moisture is not only the moisture issue not only appear or happen on those ground bearing slab, yeah, means underneath its soil. Sometimes it can be the residue moisture on the concrete itself, on the substrate itself. So because the cementitious substrate is mixed with the water, right, during the application time, right. So and where in a hospital condition, everywhere is confined, yeah. Hardly, this is the only window that I'm able to find. All is a confined area without ventilation at all. So because of all these environmental factor, right, end of the day, the substrate is unable to cure accordingly. The substrate is very high. In this case, can we still continue apply the leveling compound? Cannot, yeah. Cannot. My answer is cannot. When the substrate moisture is still high, even though it's elevated floor. This is the example. So if we directly apply the leveling compound on a high substrate, moisture substrate, high moisture content substrate, right, then eventually you will still see the blistering effect on the elevated floor. So in order to avoid this, is actually we propose the same material, Planisil VSMY, after 1 coat. And you can see before, the moisture reading is very high, more than 6. Before we apply, okay? After we applied the Planisil VSMY, you can see the moisture already dropped until 2.4%, which means to say that it's already, the moisture level is already become less, and it become insignificant to for the rising dampness for the moisture, the substrate moisture, to actually push up the Weiner material. So this is important not only for ground bearing sap, even elevated also, we need to always take note on the moisture reading. So the good practice, the best practice will be whenever that the contractor hand over the floor to the applicator, they should conduct the floor survey on every floor. Compressive strength test, floor level test, surface powdery test, water droplets test, and also the moisture reading test. This is a common practice. They should do it before they apply the next layer. Okay. And what we do also, we are also trying to propose our adhesive, resilient adhesive into the same project tower E. So this is basically a low VOC EC1 plus adhesive called Ultra Bond Eco V4 Universal. Okay. So the some project reference just to show here. Sunway Velocity, we have Penang, we have Damansara, Perak, yeah, a lot of nice photo. But I think today, what we concern is not about the nice photo, not talking about the nice finishing of the flooring material. We are more concerned on the performance of the flooring system, because everything needs to tie back to a durability of the flooring system. It has to be hygiene enough to allow the patient or the medical staff to work on top, and it has to save for everyone, yeah. So in order to provide a complete system and a more durable system solution, our solution will be always a complete system from the primer, the repair, the moisture reduction barrier, ultra plan contract, the leveling compound, and also the universal adhesive until the final floor finishing. And our solution is actually not only for healthcare facility. For some of the commercial projects or maybe the office area, yeah, we also have the complete system solution. So starting from the primer, the repair, the screening layer, the fast curing screening, the universal primer, EcoPrim T plus AP, the high performance self-leveling compound, Ultra Plan. This is the Ultra Bond Eco TXAU, is a carpet tackifier, okay? And finally followed by the carpet tiles. So everything is important, every layer is very important in order to ensure that we have a good floor finishing. Okay, so yeah, thank you everyone. Yeah, that's all for today.
All right, thank you very much, Ms. Claire. Thank you very much. Let's continue our session. We would like to invite our second speaker for today's events, Architect David Teo, talking about pioneering sustainable healthcare practical application of the GBI hospital tools. Architect David Teo is the director at PAB Architectures Neighborhood with over 20 years of experience in the built environment and is a registered architect in both Malaysia and Australia. He brings a strong global perspective, having worked on projects across 5 countries, including Australia, Vietnam, and the UAE. His professional expertise spans multiple sectors such as healthcare, diplomatic facilities, and commercials and residential developments. An active industry leader, he serves as a honorary treasurer at PAM, coordinator of the Professional Practice Trust, a Green Building Index accreditation panel member, and was recognized as one of the 40 under 40 emerging Malaysian architects in 2023. Without further delay, the floor is yours.
Thank you, Siti Haja. Good morning, everyone. Welcome to PAM Center for the non-architects, and for the architects, welcome to our lovely home. All right, so I wear 2 hats today. I am actually one of the GBI accreditation panelist members, and I'm also a director at PAB Architecture. So Hospital Cyberjaya, which is at the moment, the sole platinum rated GBI hospital in the country, was designed by our firm. But I'll cover general aspects of the GBI tool related to hospitals. And engineer CK Tang, who was our facilitator, GBI facilitator for that job, will present the technical aspects of the building. This is what I'll be presenting today. The first, we'll talk about the GBI hospital tool, and then secondly, we'll talk about how our firm sort of like has used the tool as a matrix to inform how we practice architecture and design. And then the next one is about probably what you'll be interested in, how to convince your clients to adopt the GBI tool for your projects. And then finally, some conclusions related to GBI. So let's go into the GBI hospital tool. We all know what this is about. It's about climate change, the cost to the economy, cost to the global economy. The prevalence of natural disasters is increasing due to the climate change. Our electricity tariffs are increasing. Cost of resources also increasing. So going green, when it first started about 15 years ago, GBI was a carrot. But eventually after, now it's in the 16th year, I think GBI has become more of the norm rather than the carrot, right? You don't have the carrot element anymore. A lot of what was revolutionary 15 years ago has become law. It's become codified in our bylaws. It's become codified in the Malaysian standards and things like that. So green buildings consume less energy. They have less maintenance costs. They have better occupant satisfaction, and then there's also less carbon emissions to the environment. All this we know for sure. So when you actually have a GBI project, it goes through this cycle, right? From planning to the design, and then you have the procurement. Then you go through construction, and then operation and maintenance is also an integral component of it. So while the architect's role might end after the end of construction, the GBI building has to go through the 3-year cycles of re-accreditation, meaning that the GBI tool, once you get the CVA, the Certificate of Verification for the building, it needs to be recertified every 3 years. So you have to go through an audit process, and this forces the building owner and the facility manager to look into how to maintain their building to that standard that of the rating that they have gained. So let's say you gain a platinum rating under GBI, you have to work very hard to maintain that rating after for the next audit when they go for the RVA after 3 years. So when we developed this tool, it's developed with the Ministry of Health, and under the Ministry of Health, there's Healthcare Technical Services, and together with ACEM, our Association of Consulting Engineers Malaysia, and PAM, these two organizations are the owners of the Green Building Index, and we have developed various tools, and the hospital tool is one of them, which we have developed with the Ministry of Health. As PAM members, your feedback is valuable. So if you are doing a hospital project and you feel that the tool needs to be updated, or there are things that you would like to feedback to GBI, we are willing to take your feedback and see how we can improve the tool together. Last Friday, I attended a meeting to look into with the developers of the NRNC tool. This is the main tool in GBI, non-residential new construction, and it's going to be updated soon, but we are looking at how it can benefit the industry as a whole, where you can maintain the carrot aspect of it, but update the tool so that what has become previously was the carrot now has become the stick. It's part of the law. So we are giving points for things which are already in the law. For example, MS 1525 is already codified in the law under your UBBL 2012 and then the recent 2021 amendment. So that shouldn't be something which you get more points for, because it's already the baseline. But we want to encourage a holistic overview of the tool or review of the tool so that we can move the industry forward to achieve better standards of buildings. So these are the 6 criteria for all GBI tools. We look at energy efficiency, indoor environmental quality, sustainable site planning and management, material resources, water efficiency, and then innovation. So we are looking at all the tools have the same criteria, but just the weightage between the tools is different. So when we look at the NRNC hospital tool, you find that energy efficiency and indoor environmental quality EQ make up for 56% of the total score. So we are highlighting an emphasis on operational performance, that is the energy efficiency aspects of it, and the occupant and user comfort of the building. So this is this is where you see the criteria in the sheets. You can actually download this from the GBI website and get acquainted with it. The difference here between the NRNC tool for offices, which is the base tool, and the hospital tool in, say, EE5, for example, there's advanced performance. For hospitals, they don't operate 9 to 5 like offices do. They actually operate 24 hours. So there is a different criteria for hospitals, where the top tier of the BEI is 90 for kilowatt hours per meter per year for the NRNC tool. For the hospital tool, you look at general areas and clinical areas. So the baseline is much higher because of the different operating hours. Water efficiency for hospitals, we are looking at how you can treat clinical processed water for hemodialysis, for sterilization and things like that, and how the water can be reused from the cooling towers. So when you look at material resourcing, earlier we had a presentation by MAPE, so we have a lot of standards with regards to VOCs, how the VOCs are treated in hospitals, so that the patients have like immunocompromised patients do not have to suffer from the odors or the off-gassing of all these materials. So that's a much stricter compliance required for hospitals. And then innovation is very broad. You can apply for a lot of things under the innovation criteria, especially if you want to implement things which are novel, that's not been implemented before in Malaysia. I think some of you have traveled to China and other countries. You see that innovation is very much ahead of the curve compared to us. So we are introducing something novel into a Malaysian hospital. The GBI tool supports that, total of 6 points altogether, with 1 point for the GBI facilitator that's part of the criteria. For indoor environmental quality, at the time when it was introduced, it was quite revolutionary for Malaysia to have UVGI, ultraviolet germicidal irradiation in the AHUs. So not many hospitals were doing that. Cyberjaya is one of the first few that have applied that. And then clinical safety, we're looking at how you can reduce mold or prevent mold altogether, actually. And then you're looking at also thermal comfort, giving control to the patients to control the environment, whether it's temperature, lighting levels, making sure that the acoustics of the entire hospital is well treated. And then external views. For the NRNC based tool, you're looking at, let's say you're working on workstations and then you're having a view out the window. For hospitals, this is more towards encouraging healing. So you want them to have a view of out the window, but also of nature, natural exposure to natural light and things like that. So this is the, the highlight of where the differences lie between the base NRNC tool and the hospital tool. Then we look at this EE5 aspect on energy efficiency. I put this up on the screen so you can see the BEI. There are 2 types of BEI values here. One for hospitals providing limited clinical services, and then BEI2 is for hospitals with major clinical services. So there's 2 different criteria. So when you apply for your GBI rating, then you have to look at what type of hospital are you submitting, and which criteria will you be subject to. So now we'll talk about application of the GBI tool, but I'll take off my GBI hat and speak about this as a director of PAB. So our office, as you all know, PAB has been around for quite a long time, 52 years now. In the last few years, we decided that we want to pursue a mission of creating healthier ecologies, or crafting or designing healthier ecologies. And we want to do this through genuine transdisciplinary design. I got this term from my wife. She's a speech therapist. And what happened was, when she was studying in the UCL, the UK practice is for speech therapists, occupational therapists, and psychologists to go around assessing the patients together, and then they are able to give a very holistic solution to the patient's needs. And as a multidisciplinary firm for many years, PAB from the start has been a multidisciplinary firm. But integrating these disciplines or having them work holistically is something that we are trying to do better. And we are looking at how we can elevate both the human well-being and the benefits to the environment. So that's what we're trying to do at PAB. So when we look at hospital trends, I think many of you are doing healthcare projects. You'll see that hospitals are no longer what they are in the past. We look at people-centered placemaking in the sense that hospitals become event centers, right? Let's say you go to some of the private hospitals, they have events for the public. So it could be about geriatric care, it could be about new parent classes, to prenatal and sort of like courses for the new parents and things like that. So the hospital uses their CME facilities to do this sort of people-centered placemaking. I was at Cyberjaya Hospital on Wednesday, and when I came in, I was surprised the main atrium area, they were doing a blood donation drive, and the whole area was occupied by people donating blood. So it becomes more of an event space, as well as what we thought of as a hospital previously no longer is the case. The next one is, if you are working for public listed companies, they now have to report to Bursa about their ESG initiatives. And that's where you can talk about GBI and why it's important to get some sort of accreditation for their building. So ESG and climate change is a major thing for hospitals. Inclusive design. You used to think about just, what do you call that? Wheelchair disabled access, right? When you talk about inclusive design. But now you have to think about the neurodiverse requirements. People who are sensitive to sound, people are sensitive to bright lights, things like that. You have to think about how we can be more inclusive in hospital design. Health and well-being is a given. Net zero sustainable design. Hospitals not only being green, but eventually achieving net zero. And technology integration. When you go to countries like China, it's amazing the type of integration they are having at their public hospitals with technology, with AI. So this will become a trend which will continue to become part of our norm. And as architects, we need to be prepared for that. Hospitals now, as you know, not many new hospitals per se, but a lot of retrofitting of existing hospitals. Facilities are aging. And one of the things which many people are not aware of is the EECA, Energy Efficiency and Conservation Act. So any building above, any commercial building, including hospitals, above 8,000 square meters, they are now subject to energy auditing under the EECA. And eventually, a lot of our existing building stock will have to be retrofitted. So the lowest hanging fruit to become energy efficient is to change the air conditioning plant. Then the next thing they probably want to do is look at retrofitting the entire facade to make the envelope efficient. So that's a bit more difficult because you have to cease operations and decant and you do major renovations. So it's becoming the norm. A lot of buildings will go through this, especially hospitals. I'm sure a lot of you are doing renovations and all that. One whole floor being closed down, then they're refurbishing and things like that. So it's quite normal now. Adaptive reuse, older buildings being adapted to to serve different purposes, and also looking at how energy infrastructure is incorporated into the building. Your solar panels being incorporated into the building, how you manage your energy within the building, things like that. So in our firm, we also look at how we can align with the sustainable development goals. So good health and well-being, quality education, this relates to the CME within these facilities. Both private and public hospitals have CME facilities, right? And clean water, affordable energy, affordable and clean energy, creating a decent work environment and economic growth. So I won't go through all this, but as you can see, there's about 12 out of the 17 apply to the buildings that we are designing. Okay, next. So taking these aspects of design, we sort of like charted what we find as, what they deem as human-centric things we need to look out for when we are doing design. And then we look at how we can incorporate the environmental aspects, and then how we can incorporate sustainability to the buildings. So with this, we can try and design healthier ecologies within the building that will benefit people and the planet. So when we chart this against the GBI criteria, you can see this is something which we need to, as all practitioners, we need to look at how we can design better, create better facilities, and incorporate things which will benefit our clients and the users that actually use our spaces that we design. So GBI, the first GBI Platinum Hospital, the only one at the moment, is Hospital Cyberjaya. This is a public hospital, government hospital, but it was not initiated by the MOH. It was actually something initiated by the MOF through CyberView. And part of the brief requirements was to achieve GBI Platinum at that time. And I think not many were convinced about why we need to go for GBI Platinum, but having gone through the process and after 3 years of operations, I think it's even the operators whom I met on Wednesday, they really do appreciate that it was done in that way, and the benefits is really, they're really proud of the hospital and the environment that they're working in. So it's paid off in dividends quite a lot after 3 years. So this was the criteria we used. We scored 86 out of 100 points. As you can see here, not very clear, I'll use the next chart. So the points which we didn't score, I mean, almost all of the energy efficiency points we scored. Less of the EQ points. Almost all the site and materials, site management points we scored. Material resources point, almost all we scored. Water, because we didn't recycle the water, I mean CK can talk about it later, we didn't recycle parts of the water for that's used within the hospital. We didn't score much of this. By innovation, we scored full points. So when we looked at the hospital design, oops, open to the slide. Okay, when you look at the hospital design, we looked at how we can create a memorable and high visual presence for the hospital. So the internal joke in the office is this is the most orange and the most green hospital in Malaysia. So this orange is the bright color that was the theme chosen by the KKM. Healing architecture, we are looking at the complete facilities for general hospital. It's 288 beds, and it has to be future-centric, so there's room for expansion and adaptability in the future, and also the platinum criteria for GBI. So we have to start with passive design first. I think all of you are very familiar with this, having north-south orientation when you're doing the planning, having all the other ancillary facilities planned in a way which supports the hospital in the most efficient manner possible, having the visual presence to the road, the master planning aspects have to be resolved convincingly. And next, you look at how the layouts is thought of as different mini blocks within a larger envelope, and then the main area would be the atrium where all the hospital streets will converge at the atrium. And then you look at how you can do the roofing being high solar reflectivity. So the white was chosen as the color, so you reflect most of the sunlight or solar heat gain from the roof. And then looking at how we can optimize the placement of windows, sizing of windows, where you place them, window to wall ratios, so that you can optimize the performance of the building envelope. So this is the scope of the architect working together with the medical planner to see how we can use this efficiently. As I said earlier about this atrium, it's a very nice space to be in, and because it's where all the hospital streets cross, so if you're working or a patient of the hospital, you have to enter through this main area, and then you're walking past this many times throughout the day. So this helps with your circadian rhythm, because if you are in an enclosed environment with artificial light over a long period of time, then you sort of like lose track of whether it's raining outside, whether it's night or day, things like that. So this is something where it provides a lot of relief to everyone who uses the hospital, and it's not air conditioned. It's naturally ventilated plus cool air spilling out from air conditioned spaces. So it's quite comfortable to be in this space. Clear and efficient planning, as I said, it's a vision where all the streets sort of like, all the circulation is converges here. On other floors you can see the bridges across the space, and so you kind of like have that crisscrossing. And also at the end of corridors, it's not a dark corridor. At the end of corridors you have a window, you have some sort of waiting area, seating area with a view of the outdoors. So you don't have, it's a short corridor, then you have something at the end with seating. So it's very different from most of the public hospitals we are used to, and it's done in a way that optimizes the planning in exposing the patients or the users to natural light and the view of outdoors as much as possible, where possible. And something which I think CK encouraged us to do was to test this idea of light shelves, whether or not they work. So at first I think we were skeptical, but having implemented the light shelf, there's a mirror surface here. So this is the mirrored surface of the light shelf, and then it's set with an angle with the window, and what it does is it throws the light deep into the space. You can see here what it looks like. That's the simulation, and here's a photo with the lights off. So this is the ward. It's very bright. During the day you don't turn on artificial lighting, and yeah, so that's one way it gives a better patient environment and also saves on electricity. Indoor environmental quality, as well as how we thought about color psychology. I think it's very common for hospitals to color code the floors now. This is ID done by us as well. So different areas of the hospital will have different colors applied to it, and there's a sense of clarity and identity for each department. So we'll move on to the business case now for hospitals. So if you're going to talk to your client about climate change and flooding and natural disasters and doing good, I think they're not really interested, right? What do you think? You're going to talk about saving the planet, then they'll tell you, I'm worried about my bottom line, right? So I think the 4 key things which we want to communicate to our clients are these aspects. The first, how would a green building reduce your operational expenses? So you can optimize energy, water, and resource use. The second would be about staff efficiency. How can you have a happier staff, improve wellness, the staff don't run away, they stay with your organization, they don't take sick days. They're already working in hospital, then they have to take sick leave, So how do you retain good quality talent within the hospital? Next is about patient outcomes. Better recovery rates for patients, a lot of hospital-acquired infections, right? A lot of these hospitals that are of a certain age, of a certain design, you find that they have a lot of hospital-acquired infections, a lot of horror stories. If you have friends who get admitted for something quite minor, then they end up staying there for a month because they have major complications because of infections. And then future-proofing. How can the hospital be future-proof to adapt with technology and to have better systems of monitoring? We have AI, we have robots, things like that. So how do you future-proof the hospitals? Okay, so when you look at hospitals, after you deal with the envelope as architects, the next guy that comes to the picture is the M&E engineers, and you have to look at how they can make the hospital energy efficient. And the biggest contributor to the energy consumption of the hospital would be the HVAC, air conditioning systems. That's 63% of the consumption for the hospital electricity, right? So if you can tackle this big slice of the pie, you can reduce and make your hospital very energy efficient, and that justifies the additional expense to make your hospital GBI rated hospital. So this is nowadays AI very good. You can just key in something and then they can give you an image. So what this is illustrating is your hospital is here, but what's happening is you're burning coal elsewhere. Malaysia, most of our electricity supply comes from coal, and it's actually polluting. You don't see the pollution near you, but then coal is burning somewhere else. So we want to reduce consumption of energy through better design of hospitals. So this is a real case study. This is where you can take photos, because if you look at this, these are hospitals. Most of our public hospital stock was completed before MS 1525 became the law under UBBL 2012 and 2021, right? So if your hospital was built before 2012, most likely you are in this category where your BEI is on average 350, 384 is the maximum range. So if we are looking at 50,000 square feet, Hospital Cyberjaya is about 50,000 square meters. So Hospital Cyberjaya is 50,000 square meters, 288 bed hospital. So a hospital of the same size with 384 BEI, you are paying 7.9 million in electricity bill per year. Whereas when we did our DA, our BEI that we were targeting was 207. On Wednesday, I went to Cyberjaya Hospital. I asked them, what's your BEI currently at present? They're saying that the BEI now is about 228. This is because when we design the hospital, we are doing interaction with MOH as well as and KKM or MOH as well as JKR, right? So we're doing all these interactions, and then they are telling us what their requirements are and where they're going to put certain rooms and departmental layout and things like that. So they already tell us which areas are 8 hours, 12 hours, 24 hours air conditioning, things like that. So when it actually comes to actual use, I asked them, they were consulting me about how they can reduce this number to what it was. And as you went through the hospital, what happened was, as they were operating, they changed the use of different areas, because it's normal, right? Once you take over the building, the person that takes over, the group that takes over the building is not the same group that designed the building or was involved in the design. So there are certain rooms where there's one guy operating 24 hours in this particular room, but the AHU is on for the entire floor for 24 hours. And so that's why your BEI goes up. But if we can identify all these areas, and that is why every 3 years when you do the recertification for GBI, that's very important, because then it forces the organization to say, oh, we are being audited this year, we have to do something to fix this. If not, it will just continue to be, they'll operate as usual and no one's going to check on them, and there's no incentive for them to correct the trajectory, to come back to what it was supposed to be, right? But having said that, it's still much better than, okay, so 41% reduction compared to a hospital that's not designed to be green. So 41% at present, but if we follow the design strictly, it will be 45% reduction. But if you were really ideal, that means you achieve BI of 175 as per the GBI tool, then you can get a reduction of 54%. So similarly, look at this one. This is in monetary terms. At present, they are already operating with a savings of 3.2 million ringgit a year. if they were operating to design, they would be saving 3.6 million a year. And this is very easy to get these numbers, you know. You just have to square meterage of the area of the building, and then you get Gemini or ChatGPT or whatever it is. You just get them to run the numbers based on the published TNB tariff, and then you can get this figure. So what does this mean in illustration? After 30 years, you will have planted this many hectares of forest. That's the kind of carbon output from the electricity savings. Or you removed, the first year operations, you remove 1,458 cars, so they don't pollute the environment anymore, something like that. Or a lot of you are going on holidays to Japan in the last few years because the ringgit is strengthening and the yen is weakening, probably. This is 708 return trips over, the savings over 30 years is equivalent to 708 return trips to Tokyo on Malaysian Airlines A350-900, okay? So this is the kind of data you can get and illustrate how energy efficiency relates to numbers. Next one is about wellness and staff retention. So, you know, the existing building stock that we have for public hospitals, what we have and what is designed at Cyberjaya. You look at access to natural daylight, you know, reducing the need for artificial light, as I mentioned earlier, access to external views, moderating the circadian rhythm of people working there, better layout for infection control and family visits, ability to control the environment for the patients. That's very important, which typical hospitals will not have at the moment. Then you want to improve spacing between beds, LED for lighting, similar things. So you can see the differences between what is at present and what was done previously. So waiting areas as well, more spacious, better seating, better access to natural light, things like that helps patients appreciate the environment better. Okay. So we are recently wrapping up the Institute for Forensic Medicine at along Jalan Tun Razak. You can see this golden clad building as part of HKL. So we are taking ideas from what we learned from Cyberjaya into the interior design and creating better spaces for the users. Also to our private jobs. This is something we presented to Sena Group for one of the hospitals we are doing now. So we are looking at how we can look at biophilic design, approaching hospitals differently, how interiors can be treated, using low VOC materials in the interiors, and then looking at how to incorporate technology better into the interior spaces. Okay. So things like this, interiors mood boards. So when we are looking at transdisciplinary design, we're looking at how architects, health facility planners within the same organization, interior designers, landscape architects, how they can inform one another to create better outcomes for our projects. So each of them will give inputs into how hospitals can work better. Next one is about future proofing. So as you know, when you do your, this is the design process, right, the 5 stages. But in GBI, we require, part of EE9, we require the facility management team to be present 1 to 3 months before the completion of the building. And once this happens, we are looking at how 50% of the building maintenance team can be on board 1 to 3 months and fully participate in the testing and commissioning of the building services. The next one is about providing a designated building maintenance office that is fully equipped with facilities including tools, instruments, and inventory storage, and to provide evidence of documented plan for at least 3 years of facility management, maintenance, and preventative maintenance for the building. This is very important because if they are trying to fudge this, then you know that after 3 years they will probably not get the recertification again. And there's no incentive for them to keep up with the systems or the culture. So it's a cultural shift that needs to occur from the building owners and the operators of the building, right? The maintenance team as well. So when you embed this into the tool, then it becomes very sustainable in the long run. So if you allow the building to deteriorate, so let's say the building has a 50-year lifespan, you'll see after 10 years you have all this algae growth, roof leaking, and things like that. But if the maintenance team is on board and actively fixing problems as they crop up, you will find that the building can last more than 50 years. That means there's a budget at the 10th year, right? On the 10th year, you have a budget set aside to do a major retrofitting works to the building. Then the building can continue on for 50 years. But our culture here is not like that, right? We allow the building to deteriorate to very deplorable conditions. Then we have our minister saying we need URA, we need to tear down all these old buildings. So we have to look at how we can change the mindset and culture. And I think the method is probably to have something where every 3 years, like using the GBI tool, you have to do it. If not, you don't get a recertification. Same like some of your officers, you're doing ISO. Every year you need to do your ISO recertification. And then there's a 3-year, there's a major one that you need to relook at all your systems again, things like that. So it's the same cultural mindset that needs to shift. Another thing is about BIM. In our office, we have incorporated BIM, and this is Gleneagles Block B that we worked on, completed 10 years ago. And we have been asked to come back to do renovation works on the building that we designed previously. So we already have the BIM model. And once you have a BIM model, it's very easy to coordinate the long-term maintenance of the building. Eventually, you get to do renovations very easily. All the services, information is with you. You know where everything is at. You have a model, it's easy to design and fit into the building after completion. So don't neglect this. I think every organization needs to look at how we can incorporate BIM better in our processes. This leads to sustainable income as well, so that you get to go back to do your old job. Of course, all the hospitals need to be upgraded. Oh, what's happening here? Can I go to the next slide? I think it's stuck. Next slide. Okay. We have this in the GBI tool. This is the UVGI. But there's also other, okay, what this is for those who, there's this UV light, it's an AHU, right? So the air is inside here and it's being cleaned by the UV light. It goes through this process, then it's transmitted to the rest of the hospital from the AHU. But there's also photocatalytic oxidization units, this PCO, which is widely used in the US, UK, China, and the EU. So this is a broad spectrum UV light and activates this titanium dioxide catalyst, and it generates oxidizing ions. So it's similar to the UVGI system as well. You can implement this. They also have these sterilization robots, not just in hospitals, but if you go to airports, you can see some of these robots roaming around, sterilizing spaces. So this is something which happens in other countries as well. It's becoming more common. In China, you see this intelligent transport system baked into the hospital infrastructure. When you have robots servicing things, bringing materials, bringing medicine, bringing linen and things like that, they go through corridors which don't need to be lit. So you save electricity there. And then the nurses take medicine delivered by the robots. Everything is computerized. They use this platform for smart logistics. So the inventory, number of items, things like that, what to dispense to who, everything is embedded into a centralized system. And maybe it's also integrated to your mobile phone, and then you can check information and things like that in an integrated system. So in China, they are already doing this in their public hospitals. In Tan Tock Seng in Singapore, you have this digitalization with artificial intelligence for elderly patient care, right? So this predictive patient monitoring system uses thermography, machine learning, and predictive algorithms to predict when the patient is getting out of bed, so giving nurses time to intervene and things like that. So as we progress with hospital design, then all these systems will become part and parcel of hospital, and then we have to think about how to integrate them in our design. This is a TikTok video. Does it play or not? Does it play? Nothing. Not working. Oh dear. Does it play? Oh, the video doesn't work. Okay. So in conclusion, these are the things that you benefit from by adopting the GBI tool. Strategic design leads to better patient care, lower OPEX, higher revenues, better talent retention, better results for your patients, right? And I think all of us have a role to play. So this story is about, you know about this story, this hummingbird. A lot of you know about this story. So hummingbird was taking a droplet of water, trying to put out a fire in the forest. And all the other animals asked this hummingbird, "What do you think you're doing?" Then hummingbird said, "I'm doing what I can." So they have a small beak and it's trying to put out a fire. But actually, there was this, one presenter came to PAM last year, and I got this slide from them. It says here that architects have 196 times more power to cut carbon through their work than their lifestyle. What this means is you can choose to be green. You can buy a green car, you can have an EV car, you put solar panel on your roof, you eat healthy, you know, you plant your own vegetables, whatever it is you want to do to reduce your carbon footprint. It doesn't matter as much as what you do as architects. Because let's say we have, remember what I showed you earlier? If you can make sure that you do one building that can save energy and save on carbon emissions, you are equivalent to saving or planting this many trees, right? This is the multiplier effect that we have in our roles as architects, and we have to be advocates for better buildings. All right? Thank you very much. That's my Instagram. If you want to follow me. We look forward to CK Tang's presentation. Thank you.
All right, thank you very much, Architect David Teo. I think the first step that everybody needs to do is like take that first step. Eat healthy first. Then we will continue with others. So without further delay, I would like to call on the second presenter, Engineer CK Tang, talking about sustainable design for hospital in Malaysia tropical climate. Engineer CK Tang is an engineer with over 30 years of experience in energy efficiency in building, and he is the principal of CK at Works Nemberhad. He has delivered numerous green building projects, including the WGBC APN award-winning Menara IQ HSBC at TRX, and the GBI Platinum-rated Cyberjaya Hospital completed in 2022. CK is also an author of 2 books on passive and active design, contributed to United Nations Development Programme UNDP technical guidelines, and also development building energy simulation software used in Malaysia. He has served as a sustainable peer review consultant for multiple UN agencies and authored a zero carbon building primer chapter for the World Bank during the pandemic. So I pass to you.
Thank you for the introduction. Okay. Okay, the clicker is here. I didn't know there's a reserve class up there. Reminds me as a child visiting cinemas. Yeah. Okay. Yeah. Yeah, like theater. Okay. I'll jump into my presentation. Talking about green hospitals, which we were involved in, the Cyberjaya Hospital. Just to bear in mind, when we were involved, started in this project, it was probably 2016 when the design started. So the GBI 2016 at the time, you know, now is 2006. Right, 2026 now. Okay, so we are talking about at least that 10 years time has gone. All right, based on the what we designed for at the time, what we think was green, and what is today. So today there's a lot of changes already. What is expected to be green, there's a lot more embodied carbon things being talked about and things like that. So I'll try to present to you what we did based on the 2016-2017 design. and where is the world going as well, okay, going forward. Let's see. I'll skip through this. The climate change is real, right? The Pakistan floodings and all these things is nearly every year we see a disaster which is record shattering. All right. So people say it's fake, it's no longer fake. I think people can start seeing this. Taman Sri Muda in 2021 is flooded. Okay. So we start seeing it in our own country as well. And we also need to be not just worried about flood. Because of climate change, we need to be worried about drought as well. Okay, we haven't had drought for a long time in Malaysia. It will come. All right. So when it comes, I'll be prepared for it. Okay. So we need to be. I would say that preparation is important for our own self as well. Maybe you need a bigger water tank. Okay, just to prepare for it. But more important than water tank and all these things is actually your efficiency of your water use, right? If you're still showering half an hour, okay, you probably need to start changing your habits. You can start thinking about lower flow fittings, okay, toilet flushes and things like that. And what is worrisome to me personally is the climate refugees. When I work with the UN, I have opportunity to visit a number of refugee camps, and from there you can see the problems, how critical it is. Okay, when we have refugees, the money that is going to be pumped in from the world to keep these people alive. Otherwise, I don't think we can close an eye as fellow people on Earth. Okay, on all these climate refugees. Okay, so we are committed to go carbon neutral. Okay. Now, the climate change, the biggest issue with climate change, from my point of view, is that it will lead to war. Okay, and this is already seen in countries like Syria and Yemen. And if you look at the period before the war in Syria and Yemen, there was a prolonged drought. So the farmers were not able to farm anymore. So all the farmers ended up in the cities. The cities was overwhelmed with all these climate refugees. They can't provide sanitation, food, water for everyone. Okay, all these people actually move into the city. And then the differences between the rich and poor in these cities is just immense, because these farmers, okay, are practically starving, and this leads to the internal war. Okay, so these climate refugees are actually real. And when I work with UN, I actually see all these things going on. So we need to try to prepare for all these things that's coming. Okay, the thing is that I think we have passed the point where we can stop it. Okay, it's happening already. Okay, so we need to be aware of it and try our best to mitigate as much as possible. That's what we are doing right now. Okay, so to do this, there's a big thing about ongoing right now is that we fight. We need to get net zero by the world need to get net zero by 2050. Okay, and when we talk about net zero, everybody get a shock. How are we going to go to net zero? How, especially in the hospital environment, right? So the work I've done with World Bank actually specify this very clearly. This is how you achieve net zero. The first thing you do is actually energy efficiency. Okay, you design your building, you live as energy efficient as possible. That will drive your energy down at least 50%. Okay, if you are a low-rise building, you can go for about 80%. In hospitals, it's a lot more difficult because they are running 24 hours. Hospital, we are looking at the reduction of between 25 to 30% only, right? Not so much because it's a 24-hour building. Then we talk about renewable energy, okay, on site. We put as much as renewable energy as possible on the roof. We are very lucky in Malaysia because renewable energy such as photovoltaics in Malaysia works very well. Okay, we have frequent heavy rainfalls that we actually cleanse it naturally. Okay, I've been to those countries in Middle East where every morning they need a sweeper to sweep the dust off the photovoltaics. In China also is full of dust. You know, you can see that you need to maintain it during the dry season. So there are a lot of issues in other climate, but Malaysia is perfect. You put it, you can forget about it more or less. Probably 5 years once or 10 years once you clean it. So we are in a perfect climate for it, I would say. Okay. And then the last thing we do once we have done the first two steps is buying carbon offset. Okay. The carbon offset should always be the last thing that you do. All right. Because I have to say this because right now, if you talk to corporates, the corporates will say that, okay, the first thing they'll do is buy carbon offset to go net zero. Okay, what is carbon offset? Carbon offset, you're practically just buying a certificate. Okay, you're buying a certificate that says that, hey, this certificate says that the energy that I use, okay, is offset by green project somewhere else, a solar photovoltaic projects in Kedah, in somewhere, okay? So that solar photovoltaic project, I buy the certificate, I earn the rights to claim that that energy produced belongs to me. So that's how I offset the carbon, okay? So it reduces it. So they have a third-party certification. Malaysia, Bursa Malaysia has a Vera carbon trading platform, so people can go there and buy their carbon offsets. Okay, for laymen like us, where we buy carbon offset easiest is with TNB. TNB have this tariff called GET, Green Energy Tariff. You can go there and buy it. Okay, it's quite cheap actually. So people say that carbon offset is expensive. It's not true, right? Carbon offset right now sold by TNB, I think it's only about 15 cents. I think, sorry, it's only about 10 cents, 5 cents only. Okay, 5 cents on top of your current energy bill. Okay, so your current energy bill is around 50 cents per kilowatt hour. So you just add another 10% to it, and you can call yourself net zero. Okay, that's how it works right now. So it's not expensive. So it's basically paying 10%. But why? So the first misconception is that carbon offset is expensive. Number one, it's not. It's just 10% on top of your electricity bill. And electricity bill is not high in your company expenses. You're all, who owns, I think many of you here owns your own architect firm, right? What is the percentage of your expenses is being paid for energy? You hardly hit even 10%, right? Most of it is actually your salary. You know, your electricity bill is probably less than 5% of what you pay. So you're paying 10% on top of a 5% is nothing, right? So to get to net zero is not that difficult today. So even if you own practices right now, you can say, I want to buy green energy tariff from TNB. You can go net zero. You can claim that. But you have to keep this in mind. Carbon offset is actually a tax. The more you emit, I'm saying the more energy you use, the more you have to buy. Okay, it's a tax on your profit, on your own money, right? A tax. Energy efficiency, the average payback rate of return is 100%. Okay, so your payback is about 1 year. Most of the feature that you put in, if you base it on the additional cost. Okay. For existing building, okay, let's spend a little bit of time here because I need to get this right for people to understand this properly. Okay. For an existing building, for example, your own office building, when we tell you, okay, to go net zero for your building, you need to spend 1/3 of a new building cost. 1/3. You get a shock, right? It's a lot of money. Okay, but do we need to get to net zero today? We are not talking about today. We are talking about 2050. Okay, from today until 2050, all your M&E equipment need to be replaced. Okay, your aircon is not going to last until 2050. Your lighting is not going to last until 2050. Okay, your lift is not going to last until 2050. So when we talk about this 1/3 cost, people get a shock. Okay, but it's a budget they already have, because when the aircon breaks down tomorrow, you're going to tell me you got no budget for it? Okay, your budget is already there from the start, unless you don't want the building to be operating. Okay, and if you do this right, you do your energy efficiency right. Okay, you make sure your building is airtight if it's air conditioned. You make sure you harvest your daylight. You actually reduce the heat gain. You use energy efficient light and all these things. What we found is that when you do all these things right, our aircon sizes in a typical conventional building, office building for example, our aircon size actually reduced by half. Okay, easily. Okay, not to, we haven't account for the oversizing over the years by the Malaysian engineers. They oversize the system all the time to have the safety margin. Okay, especially during design stage. When you operate, you're actually operating much lower. So your aircon actually reduced by half. So your capital cost actually reduces if you go to a net zero route rather than business as usual. So your business as usual, you spend more than 1/3 to keep everything running. Okay. If you do this right, you address the energy efficiency first, the passive features, the active features, then only do your air conditioning, you find that you can actually reduce your air conditioning upgrading costs by half. Okay. So this is how we fight climate change. We find ways that we can have a win-win outcome, right? So you do this right, you save your capital cost, you save your running costs, and then your carbon offset cost is minimum. Okay, so that's how we approach net zero by 2050. So that's the key message I want to pass on here. So let's talk about Cyberjaya right now. It's a GBI Platinum building. Efficiency is the biggest thing. Okay, we really try to push energy efficiency in this building. Okay. Yeah, David, before me talk about this space being used for blood donation. When we said, when we proposed, when Alam Bena actually proposed this space to be naturally ventilated, we get so much pushback from MOH. Okay, it must be air conditioned. It must be air conditioned. Okay, we ran simulation studies and keep trying to convince them it will be comfortable. We just keep it like this. You know, there will be leakages because at hospitals there's a lot of fresh air requirement, so it cools all the air conditioned spaces down, and it actually expel out all this air. Okay, and if we design it right, we trap this cooling. That space is good enough. You don't need active air conditioning in there. Okay, it took us a lot of convincing. Okay, and today, you know, people are using it. You know, packed with people, right? Packed with people to do their blood donations. Now, it works. Okay, so you need to look into the way to make it work. We use quite a lot of daylight in here. Okay, daylight is actually cooler than electrical lights. Okay, for the same amount of brightness. So you don't give it too much daylight. Okay, your entire roof is too much daylight, become a greenhouse. Okay, so we just need the right amount of light. And to get it right, we did a lot of modeling. Okay, we find out the spaces that will be where it needs. There'll be some spaces where it needs lights on. Okay, because it's underneath some shades. Okay, and we have to work with the engineers as well. Okay, tell them, okay, your circuiting, make sure that one is separate. Okay, so this area here can be switched off. So a lot of things, not only designing it, but getting the fine details, getting it right. Otherwise, you know, because of the one space we need light, the whole place will be turned on, right? All the lights. So then it will be a wasted effort to design it to be naturally daily. So there's a lot of these things that you go in, you see it is nice, but you don't see the hard work that goes behind it to get all these things right. Okay, every step of the way. We can get it concept done right, then someone will come in and start changing things. Okay, and we still have to correct them along the way. You know, the contractor will say, "Oh, I just run this easily," you know, and you have to track it. So those are the details, the things that goes into a grain building that nobody sees, right? Okay, and when people don't track and then it goes wrong, and then finger pointings. Okay, oh, you know, it's in my document here. It's like this, you know. It's just finger pointing all over. The engineers blame the contractor. The contractor blames someone else, you know, and things like that. So these are all the issues. Oops. Whoa. Okay. Okay. Then in the hospitals, we push a lot for VAV system. All hospitals, they normally just go for CAV. CAV means constant air volume. Okay, so the constant airspeed coming in all the time. Okay, because of the fresh air requirement, a lot of all these things. So the engineers just feels more comfortable with the CAV system. Okay, we push for VAV here because the load between daytime and nighttime is very, very different. Okay, if you go to those old hospital, I'm sure you have went into some spaces where at night it's freezing cold. Okay, you can't control it. There's no way to control it because it runs on constant speed. Okay, you drive your car, when you feel cold, you reduce your air speed, right? So this is what the VAV does. Okay, the variable air volume. So we have to convince them that today's technology, we can control this easily. We can make sure that, you know, during daytime, you know, the airspeed will increase. During nighttime, we can reduce it. And it has, because of this VAV system, it has better humidity control as well. Okay, the VAV system works in such a way that okay, when you're driving a car, okay, not automatic control. Okay, talk about manual control. Okay. Those cars with manual control of aircon. A CAV system, you turn your fan speed to the maximum. Okay, leave it there, you don't touch it. When you feel cold, you raise your temperature. Okay, when you feel warm, you reduce your temperature. That's how a CAV system works. So the fan energy running full speed all the time. A lot of energy wasted. Okay. The problem with that control is that when you are cold, you increase the temperature. When you increase the temperature, the cooling part of the aircon, the cooling coil, is warm. When it's warm, it cannot extract out humidity. It cannot extract out moisture. Okay, you need a cold surface to extract out moisture. When you drink cold water, ice water, you can see the condensation around it. So you need that cold surface to extract out. Okay, but if you want to extract out moisture, you turn it to the minimum and your fan speed is maximum, you get overcooling. Okay, so VAV system solves that. Okay, by reducing the fan speed, then your system is still cold and it can still extract moisture. Okay, so that's how it works in the VAV system. Efficient equipments, of course, these are all standard these days. When we started, you know, it's very difficult to convince engineers to specify the efficiency, high efficiency things, because they say, oh, this will increase the project cost 10%, 20%, you know. But these days it's standard already. Okay, I don't even have to fight for it anymore, at least in my projects now. Okay, it become a standard design. Okay, highest efficiency that you can get. And then the last thing is that, as David has mentioned, human behavior has a major impact on energy efficiency, right? One person working, the entire floor air conditioning is on. Okay, so how do we deal with this? So these are the things we had very early discussion with MOH all the time. Okay, but sometimes the information they give back to us is not accurate. Okay, so these are things that can go wrong. Okay. So thermal comfort is actually 6 parameters. I'm not sure you're okay. When we talk about thermal comfort, everybody thinks that it's just the air temperature, right? We talk about, oh, it's a temperature 23 degree. But it's actually more than that. Okay. If your airspeed is high, blowing across your skin, okay, you feel colder at a higher temperature. Okay. And then the third parameter is mean radiant temperature. And what is mean radiant temperature? The best way to describe it is that if you look at your temperature on your weather forecast on your phone, it says that, oh, now it's 28. But I dare you to step outside in the sun. Okay, you feel more than 28 degree, right? What is happening is because that is the radiant temperature from the sun towards you. Okay, it feels like it's 37, 39 degree. Okay, when you're standing underneath the sun, although the air temperature is 28. Okay, it's the same thing. If you go to Genting, you stand out in the sun, you also feel this heat from the radiant heat, right? Then because the air temperature is cooler, it's a balance. So thermal comfort is a balance of your heat rejection with your surrounding. Okay, so if heat is removed too fast from you, you find that you're cold. If heat is removed too slow, you're getting more heat than you're rejecting, you feel hot. Okay, so it's a balance. So to balance it, these are the 6 things that actually balance it, all right? The air temperature, the airspeed, the mean radiant temperature. Mean radiant temperature, in a way, is all your surface temperature surrounding you. Okay, this is the average of the surface temperature. The humidity, because we are right now, especially now in aircon, we are dry environment, our body evaporates much easier. Okay, now our body is evaporating all the time, or perspiring. Okay, perspiring all the time. Okay, 24 hours, 24/7. So if it's dry environment, actually extract heat out from your body faster. And then if you're wearing jackets, it's lower. Okay, there's insulation there. Okay, and it also depends on the work you're doing. So you're very active, you're sitting down, your body don't need to reject a lot of heat. But you're standing up, walking, doing work, you need to reject more heat, and the environment need to be colder. All right. But the thing is that no condition can satisfy everyone. When we talk about thermal comfort, there's always 5% people that cannot be satisfied, no matter what condition we give. So there's no way we can satisfy everyone. Okay, someone out there will be slightly different. All right. Now, for Cyberjaya Hospital, what we focus on is for energy efficiency. We look at transition space around 25 to 29, which is that common corridor that you see. It's around 29 most of the time, naturally ventilated. And yet, people are using it to do blood donation and all these things. Okay, it's comfortable enough to do that. Okay, so you do not need 23 degree all the time. Okay, there is what we call the expectation is different if you're in aircon space and naturally ventilated space. Okay, if you're in aircon space, your expectation 23, 24 degrees Celsius, yes, it's true. That's what you expect. But once you're in naturally ventilated space, your expectation changes. Okay, your tolerance becomes much wider. Okay, so that's why for transition spaces, naturally ventilated, you can go for 29. It's still possible. Okay, but even transition space, air-conditioned space, I've set in my condo, you know, for the lobby to the lift lobby, all these things, I set it at 27. And nobody has ever complained. Because they walk in from outside at 32, 27. They feel so comfortable already. Okay, they go into the lift, they go back home. Okay, so for permanent space, yes, you need colder. You need 22 if you do not have a low E glass. Okay, the radiant heat is much higher. Okay, these days, if you're not using double glazed low E glass, I highly recommend you do, because if your engineer design your aircon system correctly, that cost you spend on the glass reduces more than his cost of air conditioning if you're using single glaze. All right. So that savings goes to the glass. And why would you want to pay more for air conditioning when the glass will last forever? Okay. That air conditioning costs you, running costs are more. All right. So it's a no-brainer. Just go for high performance double glazing. Okay. I tried to convince the MS1525 committee to make it compulsory to use double glazing in Malaysia. No one agreed with me. Okay. But it is big difference. Okay. One of the reasons why I'm trying to push for that too is for my own good, right? So the next house I buy, I get a double glazed window, so that it's much cooler, and I don't have to put in the right now my home. Okay, at the end of this, I can show you my TNB bills online on my app. It's below 100 ringgit most of the months. Okay, and I'm using aircon almost all the time. Whenever the living room goes above 29, because I work from home most of the time. Okay, my office downstairs. Okay, but I can work from home. Okay, whenever the temperature goes above 29, I turn on the aircon. Okay, every night I run the aircon. I have 2 fridges, and my bill is below 100 ringgit. Okay, I can leave it for another discussion. Okay, how it is achieved. Okay, but one of the things I wanted is double glaze, low E. Okay, so it's a no-brainer. Please just go for that. Convince your engineers to size his aircon properly. If he refuses to do that, tell him to do 2 things for you. 1, size the aircon size. Show me the aircon size with the single glaze. Okay, size the aircon again with the double glaze, low E. Show you the numbers. Okay. Okay, then doors and windows opening is very critical because Malaysia is hot and humid. If we open the door right now, the aircon cost will skyrocket. Okay. In our homes, if you open the window and while running your aircon, can you cool it down? You can't cool it down. But office building and hospital, they can. Why? Because it's practically oversized. Okay, they really oversize it. So they oversize it when you keep the door or windows open, you can cool it down, but it's at the expense of running costs. Very high running costs. Okay, trust me on this. Okay, very high running costs. And if you can keep the doors and windows closed, for most building in Malaysia, you can reduce your aircon size by 25% already. Okay, that's a big saving already, just by keeping sure windows and doors are closed. Okay, so big issues there. Medical equipment, this one has to do with the first law of thermodynamics. Okay, the first law of thermodynamics is that energy cannot be destroyed. Okay, this means that any energy you use, okay, the TV, all the energy is used, will end up as heat in the room. Okay, the more lights you use, the more equipment you keep running, all ends up as heat, and then your air conditioning need to remove it. Okay, so it taxes you twice. Okay, first time you use the energy, the second time to remove it. So it is an issue. Okay, sterilizer use also actually use up a lot of energy. Okay, so those are the things we need to address. We need to make sure that they actually switch off. Okay, they switch off when they're not using critical one. Okay, they can be switched off. If they keep it running, it's going to be adds up to your energy efficiency or your energy use. Okay, so we keep having to have this reminder everywhere. All right, lights as well, because the building is designed for daylight. Okay, daylight is cooler. Okay, and we designed the building together with Alam Bena to make sure that there's a lot of daylight in the hospital, because it has been shown that people with access to daylight, they actually recover 3 days faster. Okay, so those people who don't have access to daylight, they are slower to recover. Okay, but more important than that is actually glare as well. I'll show you a little bit about the glare afterward. Okay, benefit of daylight. Okay, talking about glare, the top part of the window here is actually there's a glare prevention louvers. Okay, there are louvers there so that people who are lying down here, when they look outside, they are not seeing the sky. When you see the sky, Malaysian skies is cloudy, and clouds is more glary than blue skies. Okay, of course, direct sun is most glary, But then you go to those temperate climate countries, it's blue skies when you're not direct sun. Blue skies are not glary. Malaysia is cloudy, and our skies are glary, so we cannot have them look at the skies. Okay, so by doing that, you can see that the end result is that okay, you can see the blanks there more clearly. The end result is that okay, I don't have a good picture. The end result is you have the daylight without the glare. Okay, this is what makes daylight works in Malaysia. So you have to address glare first. Your number one priority, you cut off the glare, then the daylight will work. If you don't cut off the glare, what will happen? Okay. 20 years ago, when I start talking about daylighting, daylight harvesting, all these things, what I noticed in older office building is that they put poster up, Maradona up here posters to block off the glare. Okay, so address it while allowing the lights to come through. Okay, so that's what we do. In the hospital, you find that the switch are carefully labeled. The green one says that you can turn it on if you need it. So there are days when outside is actually very dark, and yet it's not dark enough to trigger the sensor. Okay. Talking about the sensor is placed here, very carefully selected, so that you do not get confused by electrical lighting. Okay, it's actually very just looking at the outside light. Okay, those who are inexperienced, the light sensor confused by electrical lighting, it thinks it's bright, you turn it off, then it's too dark, turn it on again. Okay, but then we have this option here. If the doctors feels that they need to do something more, they need a little bit more light than what the daylight can provide, they can still turn it on. All right. So we provide that option. Lighting control. Skip through that. Okay. Jump through. Okay. The car park. When we implemented this, the fluorescent tube light. It's no longer fluorescent light. It's LED these days. It comes with the motion sensor. Okay. So we would turn it off, we would dim it when nobody's walking. When you walk past, it actually brightens up. So that's the type, okay. We just did this for my condo that I live in. The additional cost was 2 ringgit per tube out of 30 ringgit. So we paid about 32 ringgit per tube instead of 30 ringgit without the motion sensor. Okay, so the additional cost is nothing these days. And then the one that I've selected for the condo very recently, last year, was Mega Man. It has operating hours of 50,000. Normal fluorescent tube like this has operating hours of 12,000 to 20,000 LEDs. Okay, 50,000 is almost 2 to 3 times longer operating time. Okay, so the energy saving will save you energy already. And then the reduced maintenance of keep having to replace it is huge. We can have 1 handyman now instead of 2. Otherwise, we keep changing and changing, and then again, salary is the bigger expenses than all these things, right? So getting things done right. We have the solar panel on the rooftop in this project. We have the BMS, monitoring all the energy, trying to keep our 207. We have very advanced control in this building air conditioning system in there. We work very closely with the BMS people to get it exactly how we want it to be run, so that it's intelligent. Okay. Then we talk about indoor air quality. This hospital provide UVGI. I talked about that already. Okay. Let's skip that. VOC, this morning you heard a lot all about that already. So this low VOC is important, especially for hospital, right? You don't want the smell. And this smell, if you are exposed to it for a long time, is shown to increase the risk of cancer. Okay. Talk about sustainable site. Urban heat island reduction is a white roof. Okay, we have a hard time convincing MOH that we need a white roof. Okay, they like strong colors. Okay, so a hard time, we need a white roof. White roof reduce the urban heat island, make sure the surrounding is actually cooler. Okay, so green car park priorities. Talking about green car parks. These days, I wonder if we still need it because EV cars are getting more prevalence right now. But again, in 2017, yeah, the tool says that we should have a green car parks. So right now, probably what is more important than green car parks is probably charging stations. Okay, we should insist on more charging stations. That may be the way forward. Material and resources, we try to have very high recycled content. We targeted and achieved more than 35% recycled content in the cement, in the steel bars, in all these things in building it. Regional contents, make sure that the building is made from materials that are sourced regionally. But we can score this quite easily because Malaysian cement, stone, steel are all regionally sourced. So we can get 60% in this project. Sustainable timber, the doors were certified wood. Certified wood means that these wood are harvested from forests that are regrown again. Okay, there's a system there to make sure that it's not just harvested and they run away. They will regrow it back. Okay, so it's a sustainable forest. Okay, recycling bins is provided. Green refrigerants, you can skip through that. Water efficiency, we actually use rainwater for irrigation and cooling tower. For the cooling tower the cooling tower is using all the water for the rainwater harvesting. There's nothing much left. Water efficient fittings, where it's not critical, water efficient fittings are used. But where it's critical for OT, all these things, we still use the standard flow rate for the hospital, for the doctors. They have metering leakage detection in here. So when there is a lot of water use, when during hours that is not supposed to be high water use, we will alert it. Okay. So in terms of contribution, okay, energy reduction, we actually achieve 50% reduction. Water reduction is a little bit only, 5%, not that much. For this hospital, okay. Then construction waste to landfill, we actually reduce it by 83%. Okay. So that's it. We are looking at energy efficient, water efficiency, high indoor environment, indoor quality, and high recycled and regional content in this hospital. All right. Thank you.
Thank you very much, Engineer CK. Maybe we can have both speakers on the stage for Q&A session. All right. So you can even type your question in the Slido that we shared earlier. Any question from the floor? Yes, okay.
Hello, my name is Azani. I just wondered, just now you mentioned that you reduce the construction waste by 80%. So how do you manage that?
Okay. The It's actually reduction of construction waste to landfill. Okay, so it's actually most of it is actually diverted to recycling center. For construction waste, it's actually easier because mostly they're steel, concrete waste, and all this. It's quite easy for them to segregate the waste and divert it to somewhere away from the landfill. What is difficult, we found out, and it's not addressed in all these tools yet, green tools, is actually the food waste from the construction workers. Okay, so the construction waste is not an issue already in Malaysia. A lot of contractors will practice it already. I don't have any problem with all the contractors meeting this. We'll put the, because GBI will get full points when you get 75% diversion from landfill, no problem. But then when I went there, I saw this big rubbish storage, and it's all food waste, and that one goes to the landfill. So I've been trying to instigate some issues in GBI and lead and all these things, and start thinking about what do we do with all this food waste. But it's not being addressed yet. We are still behind time, but we'll see.
I think that one quite close related
Yeah,
to
a
this
lot of
question.
single-use item, right? Because all the food are all polystyrene, plastics, you know, and one workers, they have, sometimes they have breakfast, lunch, dinner, 2 tea breaks, you know. One worker brings in about more than 1 kg of all this waste, okay, one construction worker. So at the peak, well, for one of my project, we have at least 500 workers, okay. So every day is half a ton of food waste. So that is a major problem that I'm trying to highlight and trying to get us to find ways to go around it. Okay, but because we don't have a solution yet, nobody there to put in the rules what to do about it.
Okay. All right. So I think quite close related to this question. What will be the initiative taken place in order to reduce the construction waste to landfill?
What initiative?
Yes.
Okay, first thing is we need to actually split it into various waste stream. Okay, so you segregate the waste stream into steel, concrete, wood, and any other things. Okay, so or plastics. There's, when the project is almost finished, there's a lot of plastics. Okay, your AHU all comes in plastics, so and cardboards as well. Okay, so we need to segregate all this waste stream and then start segregating, and then all this is easily diverted away from landfills. So that's the key thing, I would say. Okay, so segregating the waste stream from the start.
Similar like when we do our household
Very similar.
recycling
Yeah.
projects.
Yeah.
kan?
For household, I'm trying to champion this as well because I practice this at home, right? And I find that a lot of times I can't even decide which one to throw, which bin to throw into. Right.
Yeah, true.
Whether so I have some discussion with the waste industries. I'm suggesting to them that we provide just 2 simple bins. One bin is dry, or if you want, you can have 3 bins. All right. One bin is dry goods, dry recycling, anything dry. The other bin should be just organic. Organic shouldn't be mixed with any other thing because organic can be composed. You can actually put it in anaerobic digesters, turn it into energy. There's a lot of things you can do with it. You can turn it in fertilizer and all this, but it has to be purely organic. Okay, you don't mix anything else in it. Okay, so purely organic. Then the third one can be your mixed waste. Okay, the dry waste is easily segregated by the recycling, I mean the waste industries because it's dry. You know, they have automation these days. You know, China, I saw the people from China trying to sell the machine in Malaysia. AI, they know how to pick up what is what from the video. You know, they're so smart. You know, these are plastic, these are cars, these are what, you know, they know how to pick it up. It just goes through a conveyor belt, it picks up everything. So when it's dry, it's very easy for them to do it. When it mixed with wet, it's a big mess, right? So dry goods can be done like that. The organic can be, if you read the waste in generated in Malaysia, 50% of our waste in Malaysia are organic waste in the landfill. Okay, you do a audit there right now. 50% is organic waste. So all these organic waste are money actually, and it's just been thrown right now. Okay, yeah. So these are the things to look at moving forward.
All right, thank you. And the next question would be, how do you manage the air conditioning usage when you apply a lots of big windows where heat can come through the window?
When you do the envelope study, you have to also study the glazing type, where your wall is facing, where your window is facing, how much light comes in, whether or not that window is shaded through external device. And then you determine, what type of, whether it needs to be double glazed or laminated low E glass, what's the performance specifications. Then you can model it accurately, and then you can efficiently determine how to do your entire facade and have big windows and have efficient air conditioning. I think what CK said earlier was to encourage people to spend more money on or clients to spend more money on double glazing or better performance glass rather than spending money on the air conditioning system. So nowadays with BIM, you can actually do a lot of modeling, just key in the figures.
Okay.
I would focus on daylight first to make sure just getting enough daylight in, so you can do the modeling to make sure that it's done right. Then that's the optimum amount of glass that you should have. Okay, not too much daylight. If too much daylight, you bring in too much heat. So that's the ideal case. Optimize your daylight harvesting first.
Okay, good morning, Elmi here. From your presentation, I'm quite intrigued looking at the hospital suite where you have the double volume, and then you're using, you're tapping the cool air from the adjacent departments, I suppose. But how do you tackle, in a hospital project, especially JKR and KKM, they have these guideline mold prevention guidelines, and then in their T-board they always mention when you have different temperature, you have to use certain type of walls and whatnot. So how do you tackle that? Because there's a bit of challenge to meet the GBI requirements, yet comply with JKR requirements on this mold prevention thingy.
Okay. Yeah, with JKR and MOH, we have to go through all these mold prevention issues. We did a lot of studies to make sure they won't have any mold issues. The main issue of mold growing is when you have surface at close to 70% RH or higher, okay, when it's very cold. So to get that kind of environment, you need the surface to be cold and at high humidity, okay. And you get the surface to be cold is when the aircon is actually blowing direct air on it. Okay, if we avoid that, we push it away. We try to push it away from. Okay, one of the highest risks of condensation of mold growth in a hospital is actually the door frame. They always use a metal door frame. Okay, the metal door frame has very high conduction. Okay, so if your aircon is blowing at the door frame, okay, and outside is naturally ventilated, can you imagine what is happening on the door frame there? Yeah, and mold will grow on that. So those are the fine details that we need to look at to make sure that all these things don't happen. We are not running it below 22 degrees Celsius because our outdoor sort of dew point is around 24. So if you keep it your room temperature at 23 to 24, the chances of outside surface reaching 24 is very low. Right. So you just have to fine-tune this design.
So it's also to do with the planning. So all those rooms next to that atrium, all those areas are actually waiting areas for the clinics, or you can see there's a waiting area for the CME, things like that. So the aircon is not on 24 hours. And actually, it's actually, as CK says, it's actually quite far from the diffuser, is quite far from the doors, quite far from the surface of the walls. And it's also partially glazed. I suppose a lot of these areas are partially glazed as well. It's not fully dot walls or brick walls.
Okay, all right.
A lot of detailings, I would say, to get it right.
So it's not like one person can handle it. We have a good team work
Yes,
together
yes,
with
exactly.
it. All right. So there's one question here: is there anything an architect or engineer should take note to improve, which wasn't possible 10 years back? Is there anything that we can take note on that, in terms of improving on the GBI?
Well, like I said, the car park, the green car park, you know, is probably outdated. we should be probably thinking about charging stations. Okay. And the other thing that we should be looking at is actually do the segregation right, because last time we never really planned it properly. We just say, oh, three segregation bin is fine already. But now we figure out that, hey, we need to coordinate with the waste industry. We cannot just do what we want. Okay, there need to be some coordination with them. Well, we are learning along the way, right? And the more we learn, we find out that we need to work with others to get things done right. Right? You alone will mess things up.
Correct.
Low hanging fruit is in the GBI tool now. They still mention fluorescent light. T5 is mentioned in the tool. These kind of things should be already updated. I think very soon it will be superseded by NRNC2. CK is the one that actually contributed to the data center tool that was updated last year. And based on the data center tool, GBI is currently working out NRNC2 from some of the suggestions that have been picked up from the data center tool. So it's in progress. Hopefully by middle of this year, we hope NRNC2 can be launched. But at the same time, we have to balance two things. You want to actually be ahead of the industry, but the users or the building users or owner operators of the building, they may think that, oh, this is too stringent, then they will go for another tool. But really it's about long-term, benefits of adopting the GBI tool, right? Of course, you can use an easier tool to score, but is that really going to achieve the long-term goals of why you want to go green in the first place? You can get silver, platinum, whatever from another tool, but is the empirical evidence supporting that award or rating system? That's something which we need to study and understand.
Do you think GBI should take recycled daily waste into the building requirements? Recycle daily waste.
Yeah, it's already in the two actually.
Yeah.
You reward points for that. So if you have done that, you'll give you 1 point at least.
Okay. This is just a general point. Another question that quite general. How about the plastic packaging waste that wrapping the building construction materials? As per current practice, what is the best way to manage it?
Right now, at least in our project, what we do is that we make sure that it's actually segregated and ship it to recycling center. But we should, but once you deal with the waste industry, you find out that a lot of plastic waste are not being recycled. Okay, that's another issue to solve. Okay, but probably not for the architects to solve, it's the waste industry to solve.
I think we need another discussion on that. But so far, how long is the GBI Platinum Hospital needed to achieve return on break-even of the initial additional investment cost getting the GBI Platinum rent?
Okay, this one, there was an open tender. Okay, and Gadang won it without any additional costs actually to go for GBI Platinum. And in fact, the issue is that if they fail the platinum, they will be fined for I think 4 million. So that was the clout on the project. Okay. Yeah. 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 So it's nothing. If you do it right. One project I'm working on right now, the client keep insisting to give me a breakdown on the platinum cost, gold cost and all these costs. And I'm having a hard time to do that because actually you design it right, it's actually lower cost than your business as usual. How do you want me to present this to you? Keep scratching my head, your aircon cost actually went down. Okay.
All right, the second last question. Can you explain on how you plan or design to maintain the building internal temperature to be certain Celsius if the case is crowded and getting bigger in the building expansion?
Okay, air conditioning system, so design right is supposed to be smart. Okay, if it's a lot of people, the heat goes up, you actually provide more air conditioning automatically, like the VAV system, right? It does that. It's more challenging when you are designing for outdoor space, let's say just outside there, okay? Because we can't control the weather outside, right? There's a limitation what we can do there. So what we can do at best is that we can simulate a scenario where we assume will be the typical occupancy, okay? And when there's a lot of people, you hope that people are willing to tolerate a little bit higher range. Okay, for it. Otherwise, if you simulated the full load all the time, really packed, you will never pass the design to keep it comfortable. So, but how often that happens? Maybe one day a year or 2 days a year. So you need to have this very open and frank discussion with your client. Okay, are we going to design that for that 1 or 2 days a year, or we design it for the 363 days a year?
Okay. All right. So the last question. Any question?
Sorry. This question I've been lingering in my head. I have been involved in trying to be the GBI facilitator about 10 years ago, and looking at the list, and also my degree is architecture in environmental design. So we learn about how to live harmoniously with the earth, with the environment, recycling, saving energy and whatnot. So, but the cost of me getting involved in that, I haven't seen real life. I mean, now you guys have proven like the electricity is cut quite a lot, but holistically overall, I mean, because what we are trying to advocate is that being like a pendakwah or moral police, trying to advocate the society to live harmoniously with the earth so that the earth will last longer. You've shown all the picture of the disaster and no water and whatnot. So using the Cyberjaya Hospital as a model, how successful it is as overall in the GBI, can you gauge that it is successful so that we can use it as an example? Okay, Cyberjaya is one example that we can use as a model. It's successful and it's operating in harmoniously with the earth, something like that. Can you explain?
I guess it's about, that's why when the slide about I had one slide about the disasters and why we need to go green and all that. Then before I presented the thing about how to convince your clients, I just strike the whole thing out, because if you start talking about that, it's not going to get you anywhere. It needs to come back to hard evidence. If you're going to, for example, as TK said, if you're going to invest more on this window, why must you invest more on window? We used to do single glaze, what do you call that, non-E-coated glass and all that, low E glass. So why must we start doing this now? Then you tell them, if you do this now, then you don't have to spend so much money on your aircon. Then that saves this much money for you. Then it becomes, oh, okay. And then next year, your electricity bill, you're going to save 4 million ringgit in operational costs. I think there are a lot of buildings in town. Maybe we should write a book or something, because there are a lot of buildings in town where in Malaysia, the idea of insulating walls is unheard of, right? Why? We're not the UK. We don't have winter. But your daytime, let's say your ambient temperature outdoors is probably 38 degrees, something like that. And then at night, it drops down to about low 20s, right? You're looking at a difference of 15 degrees. What's the difference between you being here and you being in Melbourne? There's a differential of the temperature within in the same day, but we don't insulate our walls. And then even like double glazing, we don't do the double glazing. So it comes back to the dollars and cents. when the electricity tariff increases, then they say, oh, okay, then why am I spending so much money now? Then they start to think about solar panels. I think a few years ago, when, 3 years ago or 4 years ago, there was, what's that, the incentive to do your house solar panels, right? So a lot of people took that up, and then you could do it on your credit card on the 24-month or 36 months, 0 interest. And a lot of people took up that deal and they put the solar panels on the roof. But as CK said earlier, that is the second stage. The first stage is, as a house owner, how can you make your house energy efficient first? So CK, I learned from him, he went to do an energy audit of all his items in the house, your aircon, your fridge, make sure you turn off the switches on standby and things like that. You can actually save a lot of money just doing that first, and then you get a new baseline, and then on that baseline you install your solar panels, and then you find that you may become net zero. There's 2 months of last year, I paid 7 ringgit for my electricity bill, and that's the admin charges. I have a 12 kilowatt peak on my roof. It's a 3,000 something square feet house, 3-story townhouse or 3-story terrace house, and that's my electricity bill is about 50 to 70 ringgit a month on average. So it can be done, and you have to, it's awareness. Once people get aware of this is something they can account for and audit, and there's a figure placed to it, I think you can convince them much easier. Compared to the fluffy, go green, save the world, it's very difficult to convince them.
Any clients, they always look at their bottom line, right? I find that the most convincing way to talk to them is that, you know, if you don't go green, and if your competitor does, will they get more business than you? Okay, if they do, then why would you allow them to do that? Yeah, and staff, exactly, because right now a lot of young people, they want to work in a green environment, right? And especially in a green building now, we address quite a lot on health and wellness, okay, in the indoor air quality, in the light quality and all these things. So it's actually a very much nicer environment, okay. And I'm, okay, I try to, but I fail, convince my client to put a lot of charging stations for an office building, okay. Because I say that the next generation of Malaysians who's going to come and work in this building, let's say 3 years later, okay, they will have a lot of EVs, and they cannot charge at home, right? Because they live in all their high-rise in the city, okay, and you will provide this. All the youngsters want to work here. But I fail. It's a good try, though. You just keep pushing, you know, sometimes it works, sometimes it doesn't.
Hello. Just this is not in the GPI tools, but I just wondering, since you get this platinum for the hospital, have you ever calculate the differences between the embodied carbon as well as the operational carbon for this project?
So for this building, like I said, that's why it's actually based on 2016, 2017 too. Embodied carbon wasn't a big thing into it, okay? So the only thing about that links it to the embodied carbon is the recycled content, which is quite high, and regional content use, so that we are not importing things from into this building use. But we did not calculate the embodied carbon. But going forward, this is a very big thing today, okay? LEED version 4 already pushed for it. We should need to have LEED version 4 basically says that you need to have EPD, environmental product declaration, okay, or data sheet, okay, and data sheet that actually give numbers on 6 parameters. One of the 6 is actually embodied carbon or greenhouse gas potential, yeah, GWP. What is that? Okay, can't remember. It's GWP values. Okay, then there's another 5 parameters about acidification of the acid drain, you know, and things like that. So there's 6 parameters in the EPD sheets that is required by LEED to be submitted to get your points. Okay, so I can foresee that one is going to push the industry, because the last architects in last year, I've seen a lot of suppliers having the EPD sheet. So once they start providing, if you're not providing, you're going to lose out. Okay, so suppliers who don't get those sheets, again, same thing. Once your competitor does it, if you don't have it, you're going to lose out, especially if they're selling it at the same price, right?
Okay. All right. So we have last question here. How to move towards low carbon emission projects design as available materials in the market are not equipped with environmental product declaration?
It links back to the EPD thing. It's getting there. It's
Going towards that direction.
Yeah,
right
I
now.
think we are moving in the right direction, because last year I started seeing it in architects. Before that I don't see it at all. So last year I started seeing even YTL saying that all our plants have EPD sheets. Okay, but be careful. They say all, but actually only 2 has Type 3 EPD, which is supplying to Singapore because Singapore requested for it. Okay, but it's in Johor. The plants are in Johor, right? So they claim that, our Malaysian plant have it, have Type 3 EPD, but not for the central region. But now our project is actually pushing them to go for Type 3 EPD to supply to central region. So these are the small things that we keep pushing from the consultants to push the suppliers to start doing it, right? And one supplier does it, the competitors will start to take notice. Okay, that's how we start pushing it. The data center tools also start asking for it as well. Okay, the version 2 start asking for it. So it rewards you for just having that certificate. Okay, give you 1 point already. You get 1 certificate, you get 1 point already. You can get a maximum of 6 points there. So it's very easy. So you just push your suppliers, give me that certificate, you get 6 points already.
I think once there's a request, a supply, the demand is there, the supply will be there. So if the designer are looking for that direction, so I think eventually all the products suppliers will go into that directions. Okay. Anything else you want to add on? Okay. All right. Thank you very
Thank you.
much for the session. Thank you to MAPE, Malaysia's Dewan, and also both of our speakers.